Good evening, and welcome to Whispers Before Bed, a quiet space where curiosity unwinds into calm and the vast questions of the cosmos are turned into gentle stories for the mind to hold. I would love to know where in the world you are listening from and what the hour feels like there. If these whispered tales help you find a moment of peace, a like or a subscription helps this channel grow, making it easier for others to find their way here. My warmest thanks to those of you who are already subscribed. Your support is a steady light in the evening. Tonight, we unfold a question as old as the stars themselves, not with urgency, but with a slow and wondering pace. We ask not when we will find an answer, but how we might listen for one. The subject is vast, but our approach will be soft. A single step onto a path that leads into the deepest dark. Let us begin with the simplest of truths, a feeling of being alone. Imagine a bird calling out in a great forest, its song meeting only the rustle of leaves in reply. It might begin to wonder if the forest is real or if it is perhaps a very detailed cage. This is a feeling humanity knows well. We gaze up at a universe of impossible scale, at billions of stars and billions more planets, and we find a silence so profound it feels like a question. If we are truly the only ones here, then the stage is too large, the setting too elaborate. It can feel as if the cosmos is a show put on for a single audience, a vast and empty theater echoing with our own thoughts. This is the heart of the matter, the quiet yearning that starts the search. It is a search not just for company, but for context, a way to understand if the reality we perceive is the only one, or if there are other whispers in the grand composition. This feeling has a name, a paradox wrapped in silence. It is called the Fermi paradox, a simple question from a physicist asked over a lunchtime conversation. If the universe is so abundantly suited for life, where is everybody? The numbers suggest a galaxy should be teeming, filled with the radio signals and engineering projects of civilizations that have risen long before our own. And yet, we hear nothing, we see nothing. The universe presents itself to our instruments as a beautiful, yet utterly still expanse. This silence is the great backdrop against which our search is painted, a canvas of quiet that makes every potential signal a moment of profound importance in the God. It is not an empty silence, but a listening one. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Our method of listening has evolved from a dream into a rigorous science, a discipline of patience known as the search for extraterrestrial intelligence. It is a field built on the humble acceptance of our own limitations. We cannot yet travel to the stars, so we must wait for the stars to speak to us. We have built great ears out of metal and wire, vast arrays of radio telescopes that strain to hear a whisper against the cosmic static. They listen for a signal that is not natural, a pattern within the noise that carries the unmistakable signature of intention. This is the search for a techno signature, a beacon or a murmur that says, quite simply, someone is there. The principle is elegant in its simplicity. The radio waves we use for our own broadcasts and communications do not stop at the edge of our atmosphere. They leak out, traveling at the speed of light into the galactic void. Any civilization with similar technology and within a few dozen light years could theoretically be listening to the faint ghost of our 20th century television broadcasts. In turn, we listen for their leakage or for a signal far more powerful and deliberate, a greeting cast intentionally across the light years. It is a game of cosmic patience, waiting for a letter that may have been sent 1,000 years ago, or that we may not receive for 1,000 more. Yet the silence persists, a great and unbroken hush that leads to other ideas. Perhaps we are listening for the wrong things. Perhaps a advanced civilization does not use radio waves as we do, having long ago moved to more efficient and less detectable forms of communication. This is why the search has widened, its scope expanding to include other possibilities. We now look for the faint dimming of a star that might indicate a megastructure, an immense artifact built to harness a sun's energy. We scan the atmospheres of distant worlds for the chemical fingerprints of life, for gases like oxygen and methane that, in constant balance, suggest a biosphere at work. These are biosignatures, the faintest of breaths on a planetary scale. The work is slow and meticulous, a testament to human perseverance. It is conducted by dedicated teams who sift through petabytes of data looking for the one anomaly that cannot be explained by pulsars or natural interference. They follow strict protocols to avoid the frequent false alarms of human-made satellites and earthly interference. Every promising signal, every faint dip in starlight is investigated with a hope that is always tempered by skepticism. It is a science that requires not just intelligence, but profound emotional fortitude, the ability to face the great silence day after day and still choose to listen. This enduring silence has given rise to many solutions to the Fermi paradox, each one a story we tell ourselves about the nature of the universe and life within it. One of the most compelling is known as the zoo hypothesis. It suggests that advanced civilizations are indeed out there, and they are aware of us, but they have chosen to place us in a kind of cosmic quarantine. They observe us from a distance, much as we observe animals in a protected wilderness, without interfering. The reason for this could be ethical, a form of non-interference policy to allow a young civilization like ours to develop naturally, without the cultural shock of contact. Another, more cautionary tale is the dark forest theory. This idea proposes that the universe is a dangerous place, and every civilization is a hunter hiding in a dark forest, afraid to make a sound. To announce one's presence is to risk annihilation by a older, more powerful, and perhaps paranoid civilization. In this grim landscape, the only safe strategy is absolute silence. The great silence we perceive is not one of absence, but one of fear. Every civilization is listening, but none are speaking, creating a universe frozen in a state of mutual suspicion. It is a solution that explains the silence, but does so with a chill. There are other, less ominous possibilities. Perhaps the span of a civilization's technological activity is incredibly brief. They might broadcast for only a few centuries before either succumbing to their own inventions or transitioning to a state we cannot yet perceive or detect. If these windows of visibility are short, the galaxy could be dotted with the ghosts of past civilizations, their signals having already passed us by, leaving us alone in the present moment. We could be like ships passing in the night, separated not by space, but by time. Or perhaps life itself is an incredible rarity. The universe may be filled with potential, but the great filter, a step in the evolution from non life to advanced spacefaring intelligence, is so improbable that almost nothing gets past it. We might be the first, or we might be one of the very few. This answer is at once both humbling and lonely. It suggests that the forest is not a dark one, but a largely empty one. The bird calls out not because it is hiding, but because it is, for now, truly alone. Each of these stories is a thought experiment, a way of sitting with the silence and giving it a shape. The tools of our search are monuments to human ingenuity, great instruments pointed at the sky in a collective act of hope. The Allen Telescope Array, a field of white dishes in Northern California, is one such instrument designed specifically to listen for artificial signals from distant star systems. Its many ears work in concert, scanning thousands of frequencies across vast swaths of the sky, a mechanical vigil that continues through day and night. It is a quiet sentinel, its purpose not to look, but to hear, to catch a whisper that might change everything. Other tools are designed not to listen, but to see with incredible precision. The James Webb Space Telescope, a jewel floating at a point of gravitational balance a million miles from Earth, has the power to dissect the light from distant exoplanets. It can spread that light into a spectrum, a rainbow that holds secrets. Within that spectrum, scientists look for the telltale dips and lines that indicate the presence of water vapor, carbon dioxide, methane, and ozone. The specific combination of these gases could be a strong indication of life, a biosignature written in light that has traveled for decades or centuries to reach us. The search is also conducted by algorithms and citizen scientists. Projects like SETI at Home have allowed millions of people to donate their personal computer's spare processing power to analyze radio telescope data. This distributed network creates a virtual supercomputer, all working on the same grand problem. It is a beautiful notion that a laptop in a bedroom in Oslo or a desktop in a Tokyo office could be the one to first process the signal that answers humanity's oldest question. The search has become a truly global effort, a shared project that transcends borders. Yet, for all their power, these tools are looking for a needle in a cosmic haystack. The distances are so vast, the timescales so long, that the search is fundamentally one of patience. A signal directed at us from 100 light years away would have been sent 100 years ago. A reply we send today would not arrive for another century. This introduces a profound slowness to any potential conversation, a drawn out exchange that would span generations. The search is not for a chat, but for a message in a bottle, a single piece of proof that we are not the only authors in the library of the universe. The chemicals we seek are those that should not exist together for long without a constant source replenishing them. On a planet like Earth, oxygen is a highly reactive gas. It quickly bonds with other elements, rusting iron, and decaying organic matter. The only reason it remains abundant in our atmosphere is because life, in the form of plants and cyanobacteria, constantly produces it through photosynthesis. Similarly, methane is often produced by biological processes, though it can also come from geological activity. Finding both in the atmosphere of a distant world, especially in a stable equilibrium, would be a powerful, though not certain, indicator of a living world. This is the delicate art of interpretation. A telescope does not return a picture of an alien tree. It returns a graph, a series of lines and curves that represent the absorption of light at specific wavelengths. Scientists must then become detectives, piecing together a story from these faint clues. They must rule out all possible non biological explanations for the gases they see. A planet with extreme volcanic activity might also produce methane. A water world with a thick atmosphere might produce oxygen through the breakdown of water molecules by sunlight. The search is therefore not for a single clue, but for a suite of evidence that, taken together, points overwhelmingly towards biology. The future of this search lies in even more powerful telescopes, concepts that exist now on drawing boards and in scientific papers. These would be massive observatories, perhaps built in space, with mirrors so large they could directly image an exoplanet as more than a single pixel of light. They could create a crude map of its surface, distinguishing land from ocean, and perhaps even detecting the reflected light of vegetation or the glow of artificial lights on its night side. This is the dream, to see not just a chemical signature, but a world. Yet even this would be a slow and careful process. A single pixel would grow to a handful of pixels, and from that, we would infer continents and weather patterns. It would be a gradual revelation, a picture developing in a dark room over decades. The search for extraterrestrial intelligence is, in many ways, a lesson in managing expectations. It teaches us to find wonder not in instant gratification, but in the meticulous accumulation of knowledge, in the slow and steady narrowing of possibilities. It is a long meditation on a single question. The act of sending messages, rather than just listening, is a more contentious chapter in the story. This practice, known as active SETI or METI, involves deliberately beaming powerful signals towards nearby star systems that are thought to have promising exoplanets. The most famous of these was the Arecibo message, sent in 1974 from a great telescope that is now silent. It was a pictorial message, a series of ones and zeros that encoded information about our solar system, our biology, and our species. It was more a demonstration of capability than a serious attempt at contact, a single shout into the cosmos that has now traveled about 48 light years into space. This act of shouting raises deep ethical questions that echo the dark forest hypothesis. Is it wise to announce our presence? If the universe is indeed a dangerous place, then sending out signals that say, "Here we are, and we are relatively young and inexperienced," could be seen as naively risky. Many prominent thinkers, including the late Stephen Hawking, have cautioned against it, comparing it to the moment when Native Americans first heard the shouts of Columbus's crew from their ships. The outcome of that meeting was not beneficial for those on the shore. Prudence, they argue, suggests we should listen for a very long time before we decide to speak. Others counter that it is already too late. For over a century, our radio and television broadcasts have been leaking into space, creating a expanding bubble of radiation that now extends over 100 light years in every direction. Any civilization with technology slightly more advanced than our own within that bubble would have already detected this anomalous activity. They would know that something unusual is happening on the third planet of a rather ordinary star. The cat, as it were, is already out of the bag. Therefore, sending deliberate, more powerful and information-rich signals changes little and might even be seen as a polite way of saying, we know we are not alone. The debate is a fascinating one, touching on philosophy, ethics, and our own self-perception. It forces us to imagine not just who might be out there, but who we are as a species. Are we the cautious newcomers, hiding in the tall grass? Or are we the bold explorers, eager to reach out and join the galactic community? There is no easy answer, and the discussion continues quietly among the small community of scientists who ponder these things. It is a weighty decision made on behalf of all humanity about the tone of our first introduction. Imagine a different kind of signature, one not of radio waves or atmospheric gases, but of pure engineering, a civilization that has harnessed the energy of its entire star would need a structure of immense scale, a Dyson sphere, or a vast swarm of orbiting collectors that would partially obscure the star itself. From our vantage point, such a star would behave strangely. It might dim in unusual ways or emit excess infrared radiation as the captured energy is re-radiated as waste heat. Our telescopes are already looking for these anomalies, scanning the light curves of millions of stars for the telltale sign of a mega project. Another proposed techno-signature is the presence of industrial pollution in an exoplanet's atmosphere. Chemicals, like chlorofluorocarbons, are compounds that do not occur naturally. They must be manufactured. Detecting them in the spectrum of a distant world would be a shocking indication of not just life, but of technological, industrial activity. It would be a sobering find, suggesting that other species might also face the challenges of balancing growth with the health of their planet. It would tell us that we are not alone in our successes, and perhaps not alone in our failures. There are even more speculative ideas, signatures that belong to civilizations far more advanced than our own. The waste heat from immense computing networks, the light sail of a giant interstellar vessel, the manipulation of a star itself. These are concepts that border on science fiction, yet they are based on the principles of physics as we understand them. The search for techno-signatures is an exercise in imagination, grounded in data. It requires scientists to think not just about what is probable, but about what is possible, and then to design methods to look for it. This expands the search beyond a single modality. It is no longer just about tuning a radio receiver. It is about examining the entire electromagnetic spectrum. It is about looking for unexpected phenomena in the vast catalogs of stellar data collected by missions like Kepler and TESS. It is about being open to the truly unexpected. The goal is to find something that cannot be explained by any natural process, an artifact in the data that stands as a monument to another mind. It is a search for a needle in a haystack, but we are only just beginning to understand how many haystacks there are to search. The timeline of our search is a story of growing awareness. For most of human history, the planets were just points of light, and the stars were fixed and distant fires. The idea that they could be suns like our own, with their own families of worlds, was a philosophical speculation. The first concrete step came with the Copernican revolution, which placed the sun at the center of our solar system. This demotion of Earth from the center of the universe was the first psychological step towards cosmic humility. We were not the pivot around which all creation turned. The next great step was the realization that galaxies are themselves islands of stars, and that our own Milky Way is just one among billions. The universe was suddenly and terrifyingly enlarged. The work of astronomers like Edwin Hubble showed that the cosmos is expanding, filled with a number of stars so large it is effectively meaningless to the human mind. We learned that our sun is a common middle-aged star, orbiting in a commonplace region of a standard spiral galaxy. There is nothing special about our position, which immediately suggests that there should be nothing special about our status as a life-bearing planet. The discovery of the first exoplanets in the 1990s was the final piece of the puzzle falling into place. We now know that planets are not rare. They are, in fact, ubiquitous. Most stars have them. Our current estimates suggest there are more planets in our galaxy than there are stars. Millions of these are rocky worlds like Earth, orbiting in the habitable zone of their stars, where temperatures could allow for liquid water to exist on their surfaces. The universe, it seems, has provided the ingredients and the settings in overwhelming abundance. This makes the continuing silence all the more profound. The Great Silence, as it is sometimes called, is not for a lack of places to look. The real estate is there. The conditions appear to be common, and yet the rooms appear empty, the phones silent. This paradox deepens with every new exoplanet discovery. Each new world is a potential home for life, and yet another world from which we have heard nothing. The search is therefore a process of slowly, methodically checking each room in a mansion of unimaginable size, knowing that the occupant, if they exist, might be hiding, sleeping, or simply not home. Consider the sheer time scales involved. The universe is approximately 13.8 billion years old. Our solar system is about 4.5 billion years old. Homo sapiens have existed for only about 300,000 years, and our technological civilization, the kind that can build radios and telescopes, is barely a century old. We are a fleeting spark in a long, long night. It is entirely possible that galactic civilizations rise and fall on timescales of millions of years. The overlap between two such civilizations, both at a communicative stage, might be incredibly brief. We might be late to the conversation. A great galactic empire might have risen and fallen 100 million years ago when dinosaurs roamed the Earth. Their signals would have passed through our solar system long ago, and now their silence is permanent. Their ruins would be scattered across planets around stars that have since died, their stories lost to time. We are like archaeologists arriving in a vast, ancient city long after its inhabitants have vanished, left to piece together their history from dust and fragments. Conversely, we might be among the first, The early universe lacked the heavy elements necessary for rocky planets and life as we know it. Those elements were forged in the hearts of early stars and scattered across space in supernova explosions. It took generations of stars living and dying to seed the galaxy with the carbon, oxygen, and iron that make up our world and our bodies. It is possible that we are a very early example of a technological civilization, that the great wave of life is still gathering force in the cosmos, and that we are destined to be the ancient ones whom future species will wonder about. This perspective is a powerful antidote to loneliness. It places our search within a cosmic context. Our efforts are not just about finding someone else, they are about understanding our own place in the chronology of the universe. Are we the heirs of a forgotten past, or the pioneers of a future filled with life? The silence does not have to be empty. It can be a silence of anticipation or a silence of respectful memory. It is a canvas upon which we can project not just fear, but wonder. The psychology of the search is as important as the technology. To devote one's life to SETI is to embrace a particular kind of hope, one that is resilient in the face of perpetual negative results. It is a hope that is not diluted by the silence, but is rather refined by it. Each day that passes without a signal is not a failure, but a data point. It tells us that certain stars do not have civilizations broadcasting on certain frequencies at this specific moment in time. The map of silence grows more detailed, and in its blank spaces, possibility still resides. This long term commitment is a form of optimism. It is a belief that the universe is not hostile or empty, but is instead full of potential that we are only beginning to learn how to perceive. It is a vote of confidence in the future, a willingness to work on a project whose fruits may not be harvested in one's own lifetime. The scientists who work in this field are planting trees whose shade they know they will never sit under. They are building a legacy of curiosity for generations to come. There is also a profound beauty in the search itself, independent of the outcome. The act of listening is an act of reverence. It is a way of paying attention to the universe. It requires a humility that is often lost in our daily lives. We are acknowledging that we are not the center of everything, that we are part of a larger story, and that we are eager to hear what other voices might be in that story. The search is, in its essence, a conversation we are having with the cosmos, even if we are the only ones speaking for now. And for those of us who follow the search from a distance, it offers a different kind of solace. On a difficult day, it can be calming to remember that our problems and our worries are happening on a small, fragile world orbiting a common star. It is not a diminishing thought, but a freeing one. It puts our lives into a grander perspective. The search for extraterrestrial intelligence is ultimately a search for context. It is about understanding who we are by looking for who else might be out there. And that is a story that continues to unfold, one quiet night at a time. Imagine the moment of discovery, not as a shout, but as a whisper. A quiet anomaly appears on a data plot, a subtle deviation from the expected cosmic background noise. It would not be a dramatic event at first, but a slow dawning of realization among a small group of scientists. The first step would be disbelief, a thorough checking of instruments, and a desperate search for any possible error, any mundane explanation. The signal would be tested and retested, its authenticity verified again and again across independent observatories. This process of confirmation would take weeks, perhaps months, a slow and meticulous unfolding of the most important discovery in human history. The signal itself would likely be simple, perhaps a narrow-band radio transmission carrying no obvious message, but its very simplicity would be the proof. Natural objects do not broadcast on such a precise frequency. This would be a beacon, a cosmic hello meant to be found. The content of the message, if there is any beyond the carrier wave itself, might remain indecipherable for a long time. It could be a primer, a key designed to teach us its language, or it could be an artifact so advanced its purpose is beyond our current understanding. The moment would be one of profound ambiguity, a definitive answer that itself contains a universe of new questions. The world would learn of it not through a sudden announcement, but through a slow leak or a carefully worded press release from a major observatory. The news would ripple across the globe, a wave of awe and wonder, and perhaps a touch of fear. It would be a unifying moment for our species, a shared experience that transcends all borders. For the first time, humanity would have a collective identity defined not against itself, but against the cosmos. We would no longer be just humans. We would be one of at least two known intelligences in the galaxy. Yet life would go on. The sun would rise the next morning. People would still need to go to work and care for their families. The profound shift would happen internally in the way we see ourselves and our place in the scheme of things. The discovery would be a quiet hum in the background of civilization, a constant reminder that we are part of something much larger. It would not solve our problems, but it would give us a new perspective from which to view them. The universe would suddenly feel both much larger and much smaller all at once. The silence we perceive may not be a true silence, but a failure of our own perception. We are, in a very real sense, creatures of a specific environment, evolved to interpret a narrow band of reality. Our eyes see only a tiny slice of the electromagnetic spectrum which we call visible light. Our ears hear only a certain range of vibrations. Our entire scientific understanding is built upon this limited sensory and cognitive framework. It is entirely possible that the universe is buzzing with communication and activity, but in a medium or at a scale we are fundamentally unequipped to notice. Perhaps other civilizations communicate through means we cannot yet conceive. They might use neutrino beams, or manipulate gravitational waves, or employ a technology based on principles of quantum entanglement that we have not yet mastered. Their conversations could be happening all around us, in a dimension of physics we are only beginning to glimpse. We would be like deep sea creatures, unaware of the storms raging on the surface above, living in a world utterly separate from the one where the real action is taking place. Our great silence is then a product of our own isolation, not theirs. Another possibility is one of scale. A civilization a million years more advanced than ours might think and act on timescales that are incomprehensible to us. A single conversation between two such beings might take 10,000 years. Their projects might unfold over geological epochs. From our frantic, short-lived perspective, their activity would appear as slow and unchanging as continental drift. We would look for quick signals and busy traffic and see nothing, missing the immense gradual motion of their existence entirely. We are mayflies, trying to observe the growth of a redwood tree. This reframes the search. It becomes not just a technical challenge, but a philosophical and imaginative one. We must learn to think outside the constraints of our own biology and our brief human timelines. The search for extraterrestrial intelligence is also a search for new ways of seeing the universe. It pushes us to develop new physics, new mathematics, and new concepts of what life and consciousness could be. The greatest discovery might not be a signal, but a new understanding of the nature of reality itself, forced upon us by the continued respectful silence. Consider the possibility that life is not a rare accident, but a cosmic imperative, a natural and common outcome of the laws of physics and chemistry. This principle, known as cosmic biologism, suggests that given the right conditions and sufficient time, life will inevitably emerge. The universe is, in this view, inherently biofriendly. The ingredients are everywhere: water, organic molecules, and the source of energy. We see these precursors in interstellar clouds, on asteroids, and on the moons of the outer solar system. The universe appears to be prepped for life, waiting for the spark to catch. If this is true, then the galaxy should be a verdant place, filled with planets where life has taken root. But intelligence, and especially technological intelligence, might be a different matter. The path from the first self-replicating molecule to a civilization capable of building radio telescopes is long and fraught with peril. It is filled with evolutionary bottlenecks and extinction events. On Earth, it took billions of years of trial and error. Intelligence, as we define it, is just one strategy among many for survival, and not necessarily the most likely one. This leads to the idea of a great filter, a stage in the evolution of life that is incredibly difficult to pass. The filter could be behind us. The origin of life itself might have been a 1 in a trillion event, or the jump from simple prokaryotic cells to complex eukaryotic cells might be the great barrier. If the filter is behind us, it would mean that while life might be common, intelligent life is exceedingly rare, and we are one of the first or only ones to have made it this far. The more unsettling possibility is that the great filter lies ahead of us. It could be that almost all technological civilizations destroy themselves shortly after discovering the power of atomic energy or artificial intelligence or some other technology we have yet to invent. The silence would then be a somber warning, a gallery of species that failed to pass their final test. Our search for others is then also a search for our own future. Do we find a universe empty because it is a graveyard, or because it is a nursery? The answer to that question is the most important one we could ever hope to find. The vast distances between stars present the most formidable physical barrier to any dream of contact. The nearest star system, Alpha Centauri, is over 4 light years away. A radio signal traveling at the speed of light takes more than 4 years to make a one-way trip. A conversation would be an exchange spanning decades. For stars farther away, the timescales become centuries or millennia. This means that any dialogue we might have with another civilization would be less a conversation and more an exchange of timeless monologues, a cosmic message in a bottle tradition. This light speed barrier has led to more speculative ideas for contact. Could we one day send physical probes? Current rocket technology is hopelessly slow for such journeys. A probe uses conventional propulsion would take tens of thousands of years to reach even our nearest neighbor. Concepts like Breakthrough Starshot aim to overcome this by thinking small and fast. The idea is to use powerful Earth based lasers to push tiny, gram weight probes attached to light sails to a significant fraction of light speed. Such a craft could reach Alpha Centauri in about 20 years. Even if we could achieve this, the challenges are immense. The tiny probe would have to survive the intense radiation of interstellar space and the bombardment of micrometeoroids. It would have to carry a camera and a transmitter powerful enough to send data back across the 4 light-year gulf. And then we would have to wait another 4 years for its first signals to arrive. It is a project that would require a long-term commitment spanning generations, a testament to patience and foresight. These distances ensure that the universe is, in a way, designed to preserve the independence of its potential inhabitants. Civilizations are isolated by vast stretches of space and time, allowing them to develop and grow without immediate interference from others. This isolation might be a natural cosmic safeguard, a way of ensuring that a species reaches a certain level of maturity before it can ever meet another. The great distances are not just a barrier, they are also a form of protection, a quarantine of worlds that allows for the safe incubation of intelligence and perhaps wisdom. The psychology of first contact has been explored in stories, but the reality would be far more complex. There would be no single moment of meeting, no handshake across the stars. Instead, contact would be a gradual process of interpretation, a slow and careful deciphering of a signal or a data set. The first contact would be between scientists and a string of numbers, a pattern of bits. The real meeting would happen in the minds of linguists, mathematicians, and artists as they struggle to understand the message's content and intent. The message might not be a friendly greeting, it could be a warning, a beacon left over from a long dead civilization advising others to avoid a certain technological path. It could be a library, a vast archive of another world's history, art, and science, sent out into the void for posterity. It could be something entirely utilitarian, a navigation marker for interstellar travel that we simply do not understand. The content would shape our response and our entire outlook on the universe. A warning would create a universe of caution. A library would create a universe of wonder. How would humanity react? There would likely be a mixture of exhilaration and profound anxiety. Religious and philosophical systems would be challenged and would likely adapt, finding new ways to incorporate this new reality. Governments would struggle with how to manage the information and how to formulate a response. There would be debates about whether we should reply at all, echoing the current MET debates, but with infinitely higher stakes. The discovery would be the ultimate test of human global cohesion. Ultimately, the greatest impact might be on our art and our culture. The knowledge that we are not alone would ignite a new renaissance of creativity. New forms of music, literature, and visual art would emerge, inspired by the mere idea of another consciousness out there. Our culture would become cosmic. The signal would become a permanent part of the human story, a turning point in our evolution from a planetary species to a cosmic one. The mere knowledge of another would forever change what it means to be us. The search for extraterrestrial intelligence is, in its own way, a spiritual pursuit. It is a search for meaning and connection on the grandest possible scale. It asks the fundamental questions. Are we part of a community of minds? Is the universe aware of itself? The act of listening is an act of faith, a belief that the cosmos has more to say than just the laws of physics, that it contains stories and experiences beyond our own. It is a modern form of prayer, sent not to a deity, but to the possibility of a fellow traveler. This quest satisfies a deep human need for wonder. In a world that often feels explained and mapped, the question of other intelligences remains one of the last great mysteries. It is a mystery that is not hidden in some remote jungle or deep ocean trench, but is all around us, in the very emptiness of space. We need only learn how to listen to it. The mystery is broadcast on every frequency, waiting for us to tune in. This sense of wonder is essential to the human spirit. It keeps us looking up and looking forward. The search also teaches humility. It forces us to confront our own insignificance in terms of space and time, and yet it also affirms our significance as a conscious species capable of asking the question. We are a young species on a small planet, but we are beginning to participate in the universe's great conversation. We are starting to listen, and that act itself is a monumental step. Humility is not about thinking less of ourselves, but about thinking of ourselves in the context of a much larger whole. And so, the search continues, a quiet and patient effort that spans the globe. It is funded not by vast budgets, but by the passion of individuals and the donations of interested patrons. It is driven by a hope that is both scientific and deeply human. Whether we find a signal or not, the search itself has value. It refines our technology, expands our minds, and elevates our gaze. It is a peaceful, cooperative project that represents the very best of humanity, our curiosity, our intelligence, and our enduring hope that we are not alone in the great and silent dark. The history of our own planet provides a cautionary tale about the fragility of intelligence. Earth has experienced 5 major mass extinction events, each one wiping out a significant portion of life on the planet. The most famous, the KT extinction, ended the reign of the dinosaurs and cleared the way for mammals, and eventually, us. These events were caused by external shocks, asteroid impacts, massive volcanic eruptions, and drastic climate change. The universe, it seems, can be a dangerous place, full of random events that can reset the clock of evolution. A developing technological civilization must survive its own internal threats as well. We currently possess the power to destroy our own civilization through nuclear war or environmental collapse. This is a critical phase, a bottleneck that every intelligent species might have to pass through. The silence could indicate that very few, if any, succeed. The period between discovering radio waves and achieving long-term sustainability might be the true great filter. We may be in the midst of it right now, our own outcome still very much undecided. This lends a particular urgency to the search. If we were to find evidence of a long lived, sustainable civilization, it would be the most hopeful discovery imaginable. It would prove that the filter can be passed. It would provide a goal, a demonstration that it is possible to navigate the dangers of technological adolescence and achieve maturity. The mere existence of an old civilization would be a beacon of hope, a sign that we too might have a long term future among the stars. Conversely, if we were to find evidence of many civilizations that all seem to have expired at a similar technological stage, it would be a terrifying confirmation of a grim fate. The search for extraterrestrial intelligence is therefore also a search for our own destiny. We are looking for ourselves in the cosmos, for a reflection that tells us whether we are likely to survive the challenges we have created. The Great Silence is a Rorschach test. We see in it our own hopes and our own fears about the future of humanity. The future of the search is moving from the listening to the looking. The next generation of telescopes will be able to analyze the atmospheres of Earth sized planets in habitable zones with unprecedented detail. We will not be listening for a message. We will be looking for the signs of a living world. We will search for biosignatures, the chemical imbalances that life creates, the presence of oxygen and methane together, the glow of vegetation on a continental scale, the faint trace of industrial pollutants that hint at not just life, but intelligence. This is the field of exoplanetology, and it is advancing at a breathtaking pace. Missions like the James Webb Space Telescope are the pioneers, but they are just the beginning. Concepts for future space based telescopes, like the Habitable Worlds Observatory, are being designed with the explicit purpose of directly imaging dozens of Earth like worlds. Their powerful spectrographs will dissect the light reflected from these planets, searching for the fingerprints of biology in their atmospheres. The search is becoming less passive and more active, less about waiting for a signal and more about going out and looking for the evidence. This shift is profound. It means that within the next few decades, we could have statistical data on the prevalence of life in the universe. We could move from wondering if life exists elsewhere to knowing what percentage of Earth like worlds actually host biospheres. This would answer the first part of the Fermi paradox. Is life common? If we find that biosignatures are plentiful, then the paradox of silence deepens. If we find that they are exceedingly rare, then we will have a new appreciation for the incredible rarity and preciousness of our own world. The ultimate goal, of course, remains the detection of a technosignature, an unmistakable sign of technology. This could be the atmospheric pollution of an industrial civilization, the light signature of a city on the night side of a planet, or the deliberate beam of a laser communication system. The search is expanding in every direction, using every tool at our disposal. It is a methodical, scientific, and deeply human enterprise. We are sifting the starlight for answers. And with every new telescope, with every new mission, our sieve becomes a little finer. Consider the possibility that we are looking in the wrong place. Our search is predicated on the idea of carbon based life that requires liquid water, much like our own. This is a sensible starting point, as we know this kind of life works. But what if life can take forms that are utterly alien to us? What if silicon based life forms breathe methane on a cold moon? What if consciousness arises in the complex magnetic fields of a gas giant, or in the plasma storms of a star? Our definitions of life and intelligence may be hopelessly parochial. A civilization of such beings would be unrecognizable to us. Their technology would not look like our technology. Their art, their science, their very mode of existence would be so different that we might look right at it and see only a natural phenomenon. Their communications might be indistinguishable from pulsar emissions or solar flares. The great silence might be an illusion created by our own cognitive limitations. We are searching for something that looks like us, when the reality might be something far stranger and more wonderful. This does not mean the search is futile. It means we must broaden our concept of what we are searching for. Astrobiologists are already thinking about these possibilities, developing theories of life that do not require water or carbon. They are considering the potential for life in the subsurface oceans of icy moons or in the hydrocarbon lakes of Titan. The search for extraterrestrial intelligence must eventually become a search for extraterrestrial complexity, for patterns of order and information processing that cannot be explained by known natural processes. This is the final frontier of the search, to expand our own minds, to become capable of recognizing intelligence in all its potential forms. The ultimate discovery may not be an alien message, but a new way of seeing the universe that allows us to perceive the life that has been there all along. The journey outward is also a journey inward, a challenge to our most basic assumptions about what it means to be alive and conscious. The cosmos is likely far more inventive and bizarre than we can currently imagine, and our search is the first tentative step into that unknown. As we approach the end of our contemplation, the question remains, not as a demand for an answer, but as a gentle companion for thought. The search for extraterrestrial intelligence is a story without an ending, a journey where the path itself is the destination. It is a project that binds together generations of scientists and dreamers in a shared, peaceful purpose. It represents a hope that is not dependent on immediate gratification, but is content with the slow, steady accumulation of knowledge. The silence of the cosmos is not a void to be feared, but a space to be filled with our curiosity and our wonder. It is a canvas for our questions. Each quiet night spent listening is a testament to human perseverance and optimism. It is a choice to believe that the universe is a place of potential connection, not isolation. The very act of searching is an affirmation of life's desire to reach out and find other life. So let the silence be a comfort, not a worry. Let the vastness of space be a reminder of the grandeur of which we are a part. The story of our search is a beautiful one, full of brilliant minds, incredible technology, and a hopeful, patient spirit. It is one of the best stories humanity has to tell about itself, and it is a story that is still being written, one observation, one frequency, one distant star at a time. And for now, let that be enough. Let the questions drift gently in the mind, not as problems to be solved, but as mysteries to be appreciated. The universe keeps its own time, and its secrets will reveal themselves when they will. Our role is simply to be here, to pay attention, and to wonder. So rest easy with the knowledge that the search continues, quietly and surely, under the same stars that shine down on us all. The methodology of our search is a quiet symphony of precision and patience, a discipline that turns the vastness of space into manageable data points. It begins with the selection of targets, a process of careful curation among the countless stars. Astronomers prioritize sun-like stars, those stable and long-lived enough to allow for the development of complex life. They also look towards smaller, cooler red dwarf stars, which are far more common, despite the challenges their flares might pose to planetary atmospheres. Each chosen star represents a hope, a potential address for a signal. The listening itself is a study in focus. Radio telescopes are not simply pointed at the sky to hear everything at once. They are directed with purpose, tuned to specific frequencies within the microwave window, a quiet band of the spectrum where natural cosmic noise is minimal, and where a signal could travel vast distances with least interference. The frequency of hydrogen, the most common element in the universe, is a natural starting point, a cosmic watering hole where civilizations might gather to listen and to call. The search is conducted across a narrow band around this frequency, a whisper in a specific key. The data collected is immense, a torrent of information that would be impossible for any human to process. This is where algorithms take over, sophisticated software designed to filter out the constant background hum of the universe, the thermal noise of the telescope itself, the radio static from Jupiter, the distant murmurs of pulsars and quasars. The software searches for signals that are narrowband, persistent, and that drift in frequency in a way consistent with a transmission from a planet orbiting a distant star. It is looking for a needle of order in a haystack of chaos. Every candidate signal, every tiny anomaly that passes the first automated checks is then subjected to the most rigorous human scrutiny. Is it merely a passing satellite? Could it be terrestrial interference, a microwave oven, or a cell phone tower? The process of elimination is painstaking. The vast majority of candidates are discarded, their mysteries solved, but a very few remain unexplained. And these become the subjects of intense follow-up observation, a repointing of the great dishes to see if the whisper can be heard a second time. This is the heart of the scientific method applied to the grandest of questions. The duration of a civilization is a critical variable in the great equation of silence. A species must not only arise and become technological, but it must also persist for a long time to have any realistic chance of being found. If the average lifespan of a communicating civilization is only a few centuries, perhaps due to self-destruction or resource depletion, then the galaxy might be filled with the ghosts of brief flashes, signals that flared for a moment, and then went dark long before their light could reach us. We would be listening to a cosmos of echoes. This concept frames our own existence. Our technological era is barely a century old. In cosmic terms, it is the blink of an eye. Are we a fleeting spark, or are we at the beginning of a long and stable future? The answer to that question will determine whether we are likely to be found by others. To be detectable, a civilization must endure. It must learn to manage its planet, its resources, and its own technological powers with wisdom and foresight. Sustainability is not just an environmental goal, it is a prerequisite for cosmic citizenship. The search for extraterrestrial intelligence is, in this light, also a search for models of longevity. If we were to detect a signal from a civilization a million years our senior, It would be the most valuable knowledge we could ever acquire. It would prove that long-term survival is possible. It would offer hope that the great challenges of technological maturity can be overcome, that civilization would become a beacon, not just of its own existence, but of potential futures for ourselves. Their mere presence would be a lesson. The silence, therefore, can be interpreted in two ways. It could mean that such old civilizations are exceedingly rare, that the great filter of self annihilation is almost insurmountable, or it could mean that such civilizations exist but have transitioned to a state that is currently imperceptible to us. They might have moved beyond radio technology, or they might exist in a form we cannot yet imagine. The continued search is our way of probing these possibilities, of asking the universe if long-term hope is justified. The philosophical implications of contact would ripple through every aspect of human thought. For philosophy, it would force a reevaluation of anthropocentrism, the idea that humanity is the central fact of the universe. We would have to accept that we are not unique in our capacity for reason, language, and culture. This would be a demotion in cosmic status, but also a liberation from a kind of intellectual solitude. We would have to develop a post-contact philosophy, one that considers the nature of mind and morality beyond the human experience. Our legal and ethical systems would face unprecedented challenges. What rights would an extraterrestrial intelligence have? What responsibilities would we have towards it? Would we treat it as a person, a nation, or something entirely beyond our categories? The development of a cosmic ethic would become a paramount task for global thinkers. It would require us to extrapolate our principles of justice and respect to a being that might be utterly different from us in biology, psychology, and culture. It would be the ultimate test of our moral imagination. The discovery would also pose a profound challenge to many earth-based religions, theologies that place humanity at the center of a divine plan would need to expand to accommodate the existence of other created beings. Some faiths might find this compatible, seeing extraterrestrials as part of a grander creation. Others might struggle with the theological implications. This could lead to a period of religious ferment and reinterpretation, a new reformation sparked by a signal from the stars. It would be a crisis of meaning that could ultimately deepen our spiritual understanding. On a more practical level, contact would create a new human identity. National, ethnic, and cultural differences that seem so significant today would shrink in importance when contrasted with the ultimate difference, human versus non-human. The discovery would likely create a powerful planetary consciousness, a sense that Earth and its people are one community facing the cosmos together. This unifying effect might be one of the greatest benefits of contact, helping humanity to overcome its internal divisions and to confront its future as a single species. The infrastructure of the search is a global network of curiosity. It spans continents, from the great radio dishes at Green Bank in West Virginia to the Parkes Observatory in Australia, from the Meerkat Array in South Africa to the FAST telescope in China. These instruments, though owned by different nations, often work in concert through international agreements. Data is shared, observing time is allocated to the most promising projects, and discoveries are verified by independent teams. This is science at its most cooperative, a silent global effort for a common goal. The funding for this work is often precarious. Unlike missions with clear commercial or military applications, the search for extraterrestrial intelligence operates on the edge of scientific respectability for some and relies heavily on private philanthropy and public donations. Organizations like the SETI Institute are nonprofits funded by individuals who believe in the importance of the question. This gives the endeavor a pure, almost noble character. It is not done for profit or power, but for the sake of knowledge itself, for the answering of a fundamental human wonder. The people who do this work are a special kind of scientist. They must possess not only technical expertise, but also a deep well of patience and optimism. They may spend an entire career without a single positive result, yet they continue to refine their techniques, to build better instruments, and to train the next generation. They are motivated by the magnitude of the question, understanding that even a negative result is a valuable piece of information about the universe. Their dedication is a testament to the human spirit's relentless pursuit of understanding. This global network is more than just a scientific endeavor, it is a symbol of hope. In a world often divided by conflict, the silent, coordinated listening of these telescopes represents a unifying human project. It is a reminder that we are capable of working together on long-term, peaceful goals that benefit all of humanity. The dishes pointing at the sky are not weapons of war, but instruments of curiosity. They are a physical manifestation of our better angels, our desire to reach out and connect with something greater than ourselves. The concept of intelligence itself may be due for a revision. We tend to measure intelligence by our own standards: tool use, language, mathematics, and technology. But these may be just one evolutionary path among many. On another world, intelligence might express itself through complex chemical signaling, through the building of vast living structures, or through a deep, intuitive understanding of ecological systems. Their technology might be biological, a seamless integration with their environment that leaves no technological signature for our telescopes to find. This kind of intelligence might be far more common than our own, a species that achieves a sustainable balance with its planet, one that does not develop radio astronomy or spaceflight, could thrive for millions of years without ever making a sound on the galactic stage. They would be invisible to our current search methods, yet they could be rich in consciousness, culture, and wisdom. The universe might be full of such silent philosophers, living in harmony with their worlds, unaware of the cosmos beyond and undetectable by it. If this is the case, then the Great Filter might not be a moment of destruction, but a choice. The filter could be the transition from a rapidly expanding, resource-intensive technological phase to a stable, sustainable, and perhaps quieter existence. Civilizations that make this transition become permanent parts of their biospheres, not separate from them. They might focus inward on art, philosophy, or spiritual development, rather than outward on exploration and communication. Their signature would be a healthy, stable planet, a biosignature without a technosignature. This offers a different resolution to the Fermi paradox. The silence is not a sign of failure or fear, but of maturity. The galaxy may not be empty, It may be full of grown-ups. They are not hiding. They are simply living in a way that is imperceptible to a noisy, adolescent civilization like ours. In this view, our search for signals is a search for others at our own stage of development. The true test for humanity may not be whether we can find others, but whether we can grow up enough to join the silent, sustainable majority. The role of artificial intelligence in the search is growing rapidly. The vast data sets produced by radio telescopes and sky surveys are too large for human analysts to process in detail. Machine learning algorithms are now being trained to sift through this data, looking for patterns and anomalies that might be missed by traditional methods. These AIs can learn to distinguish between a promising signal and radio frequency interference with ever increasing accuracy, becoming essential partners in the search. AI could also play a role in deciphering a message should one be received. The structure of an alien communication might be so complex or based on principles so foreign that human minds would be unable to decode it. An artificial intelligence, unconstrained by human cognitive biases and capable of perceiving patterns in high-dimensional data, might be our best hope for translation. It could serve as an intermediary between two modes of thought, a bridge between species. This introduces a fascinating possibility. Our first contact with an extraterrestrial intelligence might be mediated by our own artificial intelligence. The conversation might happen between two non-biological entities, with humans as interested observers. The message might not be a string of pictures or mathematics, but a set of algorithms or a new type of logic that only another AI could initially comprehend. Contact could be an event that happens in the realm of pure information at a speed and complexity beyond human perception. This does not diminish the importance of the search. It simply expands its nature. It suggests that our technological development, including the creation of AI, might be a necessary step in becoming a communicative species on the galactic stage. Our machines might be the key that unlocks the conversation. The development of advanced AI is often portrayed as a risk, a potential threat to humanity. But in the context of SETI, it might be the very thing that allows us to finally hear and to be understood by the rest of the cosmos. The psychological preparation for contact is a field in its own right, though a speculative one. How does a civilization prepare for an event that could be utterly transformative, but whose form and timing are completely unknown? There are no protocols, no established rules of engagement. The United Nations has an Office for Outer Space Affairs, which has discussed the topic, but any real response would likely be developed in the moment by the scientists who make the discovery and the governments that react to it. Some argue that the very act of searching is a form of preparation. By engaging with the question seriously and scientifically, we are slowly acclimating our culture to the idea that we are not alone. Science fiction plays a role here, providing a vast library of thought experiments about first contact. These stories allow us to mentally rehearse for the real event, to explore the myriad possibilities and their implications. They are a cultural immune system, building up antibodies of ideas before the pathogen of reality arrives. The most important preparation may be the cultivation of certain virtues on a global scale: patience, humility, and wisdom. The process of confirming a signal would be slow, requiring international collaboration and careful verification. A rash response, or a response driven by fear, could be disastrous. We would need the humility to accept that we are not the apex of creation, and the wisdom to understand that an advanced civilization would likely be so far beyond us that our concepts of competition or threat might be irrelevant. In the end, we cannot truly prepare for something so unprecedented. The best we can do is to foster a global culture that values curiosity over fear, cooperation over conflict, and long term thinking over short term reaction. The search for extraterrestrial intelligence is, in itself, a practice of these virtues. It teaches us to listen, to be patient, and to think in terms of centuries and light years. If and when contact comes, these habits of mind will be our greatest asset. The interstellar medium itself might hold clues. Instead of looking for directed signals, scientists also search for evidence of astroengineering on a colossal scale. Could a civilization build a Dyson sphere around its star to capture all its energy? Such a structure would block the star's visible light, but would radiate waste heat in the infrared. Astronomers have searched for stars with excess infrared radiation, though natural phenomena like dust clouds can often explain the observations. The search continues for an unmistakable signature. Even more speculative are ideas like star lifting, where a advanced civilization might harvest material from its star to extend the star's lifespan or to build massive structures. This could alter the star's chemical composition in detectable ways. Or perhaps a civilization would use giant shields to control their star's output, preventing it from flaring and damaging their planet. These are feats of engineering so vast they border on the godlike, and their detectable signatures would be subtle but potentially findable in detailed stellar spectra. The energy requirements for interstellar communication itself could be detectable. To send a powerful signal across thousands of light years would require a tremendous amount of energy. The sudden, focused expenditure of such energy might be visible as a transient event, a brief flash on a radio telescope's detectors. Surveys that monitor the sky for transient phenomena, like supernovas or gamma ray bursts, might one day catch such an artificial flash, a deliberate beacon too powerful to be natural. These searches for mega engineering projects are the most speculative arm of SETI, but they are based on sound physics. They ask what a civilization a million years more advanced than ours might be capable of achieving. The signatures would be long lived, lasting for millennia or longer, increasing the chance of detection. They represent a search not for a civilization like ours, but for one that has mastered its solar system and its star, a civilization that has become a lasting and visible force on a cosmic scale. The future of the search is not limited to professional scientists. Citizen science projects are opening the door for anyone with an internet connection to participate. Platforms like Zooniverse allow volunteers to examine data from telescopes, classifying images, or analyzing light curves for anomalies. This not only accelerates the research, but also builds a global community of people engaged in the great question. It democratizes the search, making it a truly human project. The development of new sensor technologies will also play a role. More sensitive radio receivers, better algorithms for noise filtration, and new types of optical and infrared telescopes will all increase our ability to detect faint signals. The search is a constant race against noise, and every incremental improvement in technology brings us closer to hearing a whisper that was previously drowned out. Innovation in instrumentation is the engine that drives the search forward. Perhaps the most exciting future direction is the move towards multi-messenger SETI. This involves not just listening for electromagnetic signals, but also searching for evidence in other mediums, such as gravitational waves or neutrinos. An advanced civilization might use these channels for communication, especially if they offer advantages over light waves. By expanding the spectrum of our search, we increase the chances of stumbling upon a channel that someone else is using. The ultimate future step might be proactive. Instead of just listening, we might one day send out more powerful and targeted messages, or even physical probes. This is a controversial step, but as our technology advances, it may become a more feasible and debated option. The search for extraterrestrial intelligence is a dynamic field, constantly evolving with our technology and our understanding of the universe. It is a journey that has just begun, and its future chapters promise to be even more fascinating than its past. As we bring our contemplation to a close, it is worth reflecting on the journey itself. The search for extraterrestrial intelligence is one of the most profound and enduring projects of the human spirit. It is a question mark placed against the silence of the universe, a refusal to accept solitude without evidence. It is an act of hope that began when the first human looked up at the stars and wondered, and it continues today with the most sophisticated tools we can devise. The silence, for now, remains, but it is not an empty silence. It is a silence filled with data, with the negative results of countless observations that have slowly charted the empty spaces on the map of possibility. It is a silence that has driven innovation, inspired cooperation, and expanded our understanding of the cosmos. Even if we never find a signal, the search will have been worth it for the knowledge gained along the way. The question of whether we are alone is ultimately a question about the nature of the universe itself. Is it a universe that favors life and consciousness, or are we a fantastically unlikely accident? The answer to that question will shape humanity's cosmic identity for millennia to come. It will tell us whether we are residents of a crowded galaxy or caretakers of a rare and precious garden. So let the search continue. Let the great dishes continue to listen. Let the telescopes continue to stare. Let the scientists continue their patient work, and let the rest of us continue to wonder. The universe is old and vast, and its secrets are revealed slowly, on its own schedule. Our role is to be curious, to be patient, and to be ready for the moment when the silence might finally be broken. Until then, the wonder is enough. The quiet rhythm of the search mirrors the gentle cadence of the cosmos itself, a slow and patient pulse against the backdrop of infinite space. Each observation is a single note in a grand symphony of curiosity, played on instruments of exquisite precision. The great radio dishes turn with deliberate grace, their parabolic curves tracing arcs against the sky, focusing whispers from the void into streams of data. Their movement is a mechanical ballet, a dance of patience performed every night under the stars. Within the control rooms, the atmosphere is one of focused calm. Screens display waterfalls of data, cascading colors representing frequencies and intensities. The scientists who monitor them do so with a quiet diligence, understanding that the moment of discovery would not be announced with alarms, but with a subtle anomaly that requires careful verification. Their work is methodical, a practice of attention that borders on meditation. They are listening for a secret the universe might not be ready to tell. The data itself flows through pipelines of algorithms, digital streams, sifted for patterns. These mathematical filters are designed to recognize order within chaos, to find the signal within the noise. They operate silently, tirelessly, processing information at scales incomprehensible to the human mind. Yet they are guided by human intention, by the questions we have asked of the cosmos. This collaboration between human curiosity and machine precision is the essence of the modern search. And so the rhythm continues, day after day, night after night, a cycle of pointing, listening, recording, and analyzing. It is a rhythm that has continued for decades and will likely continue for decades more. It is not a frantic search, but a persistent one, a testament to the belief that some questions are worth asking for a lifetime, and that some silences are worth listening to for generations. The search itself becomes a kind of answer, a statement about who we are and what we value. The chemicals of life tell a story written in atoms and molecules, a narrative of complexity emerging from simplicity. In the vast clouds of interstellar gas, astronomers have found a rich soup of organic compounds, amino acids, sugars, and the precursors to DNA. These discoveries suggest that the universe is not only capable of creating life, but seems almost predisposed to it. The ingredients are scattered everywhere, like seeds waiting for the right conditions to take root. On planetary surfaces, these ingredients find their stage. Liquid water provides a medium for molecules to meet and interact, to form increasingly complex structures. The transition from chemistry to biology remains one of science's great mysteries, but the building blocks are all there. The universe provides the raw materials, and nature performs the experiment again and again across countless worlds. We are one result of that experiment, living proof that it can work. When we look at other worlds in our solar system, we see tantalizing hints that the experiment might be running elsewhere. The subsurface oceans of Europa and Enceladus, the ancient riverbeds of Mars, the methane lakes of Titan, all are environments that could potentially host life, even if only in microbial form. These are our closest laboratories for understanding how life might begin and persist in diverse conditions. They are the first chapters in a story that might be universal. The search for these chemical stories is conducted with spectrometers and telescopes, instruments that can read the language of light. Each element and molecule absorbs and emits light at specific wavelengths, creating a unique fingerprint. By analyzing the light from distant exoplanet atmospheres, we can read these fingerprints and infer the presence of water, methane, oxygen, and other potential biomarkers. It is detective work on a cosmic scale, solving mysteries across light years of space. The distances between stars create not just physical isolation, but temporal loneliness. A signal sent from a civilization 1,000 light years away would contain a message from a millennium past. We would be hearing their history, not their present. Any response we send would take another 1,000 years to reach them, by which time both our civilizations might be unrecognizable to each other. Communication becomes less a conversation than an exchange of time capsules. This temporal aspect gives the search a archaeological dimension. We are not searching for contemporaries, but for artifacts of civilizations that may have risen and fallen long before humans walked the earth. A detected signal might be the last testament of a species that expired ages ago, a monument in radio waves that outlasted its creators. We would be like archaeologists uncovering an ancient city, learning about a culture through its surviving artifacts. The vast timescales also mean that any civilization we detect will almost certainly be much older than ours. Even a signal from 100 light years away comes from a civilization that had radio technology a century before we did. They would have had that much more time to develop, to evolve, to change. They might be so far beyond our understanding that communication would be fundamentally challenging. We would be children trying to understand the works of ancient philosophers. This temporal disconnect suggests that the search is not just about finding others, but about finding our potential futures. An ancient civilization could show us what is possible over long periods of time, what paths a technological species might take over millennia. Their mere existence, even as a signal from the past, would give us perspective on our own place in cosmic history. We would no longer be navigating blindly, but could see something of the long road ahead. The ethics of listening carry their own quiet weight, a responsibility that grows with each passing year of silence. As our technology improves, we become capable of hearing fainter whispers, of detecting more subtle signs. With this capability comes the obligation to listen responsibly, to avoid contamination of the signal with our own noise, to verify thoroughly before claiming discovery. The scientific method becomes an ethical imperative when the stakes are so high. There is also the ethical consideration of what we might hear. A detected signal could contain information that is disruptive to human civilization, whether intentionally or not. It might contain scientific knowledge that could be used dangerously, or philosophical ideas that could undermine human cultures. The decision of how to handle such information, how to translate and disseminate it, would be one of the most important ethical challenges humanity has ever faced. The potential for cultural contamination works both ways. If we were to detect a weaker signal from a less advanced civilization, we would face the question of whether to make contact. The prime directive from science fiction becomes a real ethical dilemma. Do we have the right to interfere with another culture's natural development? Even passive observation could be considered interference if discovered. Our mere listening could have consequences we cannot predict. These ethical considerations have led to the development of protocols for post detection, though they have no legal authority. They represent humanity's best attempt to think through the implications of discovery before it happens. They emphasize international consultation, verification, and careful consideration before any response is sent. They are a recognition that the search is not just a scientific endeavor, but one that carries profound responsibility for all of humanity and potentially for other civilizations as well. The evolution of the search tells a story of human technological progress, a narrative of increasing capability and refinement. In the beginning, the search was conducted with borrowed equipment, using telescopes designed for other purposes. Frank Drake's Project Ozma used an 85-foot radio telescope in 1960, listening to just two stars for a few hundred hours. It was a modest beginning, but it established the methodology and the dream. As technology advanced, so did the search. Larger telescopes were built, more sensitive receivers were developed, and digital signal processing allowed for the analysis of millions of channels simultaneously. The search moved from looking at individual stars to scanning large swaths of sky, from listening on a few frequencies to monitoring billions of channels at once. Each technological improvement expanded the search space, increasing the probability of detection. The development of the Internet revolutionized the search, not just through faster data processing, but through distributed computing projects like SETI at home. This allowed millions of people to participate directly in the search, creating a global community of participants. The search became democratized, no longer just the domain of professional scientists with access to large telescopes, but something anyone with a computer could contribute to. Today, the search is entering a new phase with the advent of artificial intelligence and machine learning. These technologies can find patterns in data that humans might miss and can process immense data sets more efficiently. The search is also expanding beyond radio astronomy to include optical SETI, looking for laser pulses, and infrared observations, looking for heat signatures of advanced civilizations. The tools evolve, but the question remains the same. Are we alone? The psychology of the searchers is a study in long-term optimism, a testament to the human capacity to maintain hope in the face of prolonged negative results. These scientists have dedicated their careers to listening for a signal that may never come, yet they persist. Their motivation comes not from the expectation of immediate success, but from the importance of the question itself. They understand that even a negative result has value, as it helps us understand the universe better. This long-term perspective requires a special kind of psychological resilience. Most scientific fields offer regular, small successes: papers published, experiments completed, incremental advances made. SETI offers none of this. A career in SETI could mean decades of work without a single positive result. The searchers must find satisfaction in the process itself, in the refinement of techniques, the building of better instruments, and the training of the next generation. The community of SETI researchers is bound together by this shared purpose and understanding. They form a unique scientific subculture, one that is comfortable with uncertainty and long time horizons. They support each other through conferences, collaborations, and shared data. This community provides the psychological sustenance needed to continue the search year after year, decade after decade. They are keepers of the question, guardians of the possibility. For the broader public, the search offers a different psychological benefit. In a world often focused on immediate concerns and short-term thinking, the search for extraterrestrial intelligence provides a connection to something larger. a perspective beyond our daily worries. It reminds us that we are part of a vast cosmos, that there are mysteries yet to be solved, and that humanity is capable of asking big questions and pursuing them with patience and determination. The mathematics of the search is a language of probability and statistics, a way of quantifying hope and uncertainty. The Drake equation, formulated in 1901, provides a framework for estimating the number of communicative civilizations in our galaxy. It multiplies together factors: the rate of star formation, the fraction of stars with planets, the number of habitable planets per system, the fraction where life develops, the fraction where intelligence evolves, the fraction that develop technology, and the length of time such civilizations release detectable signals. Each factor in the equation represents a field of scientific inquiry. Astronomy has given us good estimates for the first few factors. We know stars form regularly and that planets are common. Astrobiology is working on the next factors: how common life might be and how often it evolves intelligence. The final factors remain complete unknowns: how long technological civilizations last and whether they make themselves detectable. The equation is less about getting a right answer than about understanding what we need to know. The equation also reveals the immense uncertainties in the search. Depending on the values chosen for the unknown factors, the estimated number of civilizations can range from 1 plus to millions. This wide range reflects our fundamental ignorance about the later steps in the process. The search is essentially an attempt to measure these unknown factors empirically by looking for actual signals rather than making estimates. Despite its limitations, the Drake equation serves an important purpose. It organizes our ignorance, showing clearly what we know and what we don't know. It provides a structure for the search and a way to communicate its challenges and possibilities. It turns a philosophical question into a scientific one, subject to measurement and verification. It is a mathematical expression of the hope that we might not be alone in the vastness of space. The cultural impact of the search extends far beyond the scientific community, influencing art, literature, and philosophy for generations. Science fiction has explored countless scenarios of first contact, from friendly exchanges to destructive invasions. These stories serve as cultural rehearsals for the real possibility, allowing us to explore the implications emotionally and psychologically before facing the reality. They have shaped how we imagine aliens, from little green men to incomprehensible beings of energy. The search has also influenced philosophy, forcing us to confront questions about humanity's place in the universe. If we are alone, that suggests something profound about our rarity and responsibility. If we are not alone, that suggests something equally profound about our lack of specialness. Both possibilities challenge anthropocentric views of the universe and force us to think on cosmic scales. The search keeps these philosophical questions alive and relevant. In popular culture, the search has created a sense of anticipation, a feeling that humanity is on the verge of something momentous. This is reflected in the public fascination with UFO sightings, though most are explainable, with movies about alien contact, and with the work of actual SETI scientists. The idea that we might soon make contact captures the public imagination in a way few other scientific pursuits do. It represents the ultimate discovery, the final frontier of knowledge. The search has also created a global community of interest, people from all cultures and backgrounds who share curiosity about this question. Online forums, social media groups, and citizen science projects have connected people around the world in the common pursuit of the answer. This shared interest transcends national boundaries and cultural differences, creating a sense of global community united by a single, profound question. In this way, the search itself is already creating a planetary consciousness. The future of the search points toward greater integration with other scientific disciplines, a convergence of fields that were once separate. Astrobiology, once considered speculative, is now a respected scientific field studying the potential for life elsewhere. Astronomy continues to discover more exoplanets, characterizing their atmospheres and environments. Planetary science explores the possibilities for life in our own solar system. SETI brings these together, asking the ultimate question that connects them all. New technologies will continue to drive the search forward. More sensitive telescopes, both on Earth and in space, will allow us to detect fainter signals and study more exoplanets in detail. Quantum computing might revolutionize signal processing, allowing us to analyze data in ways currently impossible. Advances in artificial intelligence will help us recognize patterns and anomalies that human analysts might miss. The search will benefit from progress across multiple technological fronts. The search is also expanding conceptually. While Radio SETI continues, other approaches are gaining attention, looking for laser signals, for Dyson spheres, for atmospheric pollution, for city lights on exoplanets, even for evidence of cosmic engineering on unimaginable scales. The search is becoming more diverse, more creative, and more open to unexpected possibilities. We are learning to look for many different types of evidence, not just radio signals. This expansion reflects a growing maturity in the field. We are moving beyond the simple expectation of finding radio signals like our own and beginning to appreciate the true diversity of what might be out there. The future of the search is not just about better technology, but about better thinking, more imaginative, more inclusive, and more open to the truly alien. We are learning to listen not just for what we expect to hear, but for what we cannot yet imagine. As our contemplation draws toward its gentle conclusion, we return to the essential mystery, the question that has guided humanity's gaze upward for millennia. The search for extraterrestrial intelligence represents some of our best qualities: our curiosity, our perseverance, our hope for connection, our willingness to think in cosmic terms. It is a project that spans generations, a question we keep alive for those who will come after us. The silence, for now, remains unbroken, but it is a fertile silence, filled with potential and wonder. Each night of listening adds to our knowledge, even if only by telling us where not to look. Each new telescope, each new algorithm, each new generation of scientists brings us closer to the possibility of an answer. The search itself becomes a kind of conversation with the universe, a way of saying we are here and we are listening. Whether we find others or not, the search changes us. It expands our perspective, humbles our pretensions, and connects us to the cosmos in a deeper way. It reminds us that we are part of something vast and mysterious, and that our story is still being written. The question of whether we are alone is ultimately a question about the nature of reality itself and our place in it. So the search continues, a quiet persistence against the great silence. The telescopes keep listening, the scientists keep analyzing, and humanity keeps wondering. The answer may come tomorrow, or in 1,000 years, or never. But the question is too important not to ask, the possibility too profound to ignore. And so we listen, patiently, hopefully, to the whispers of the cosmos, the constants of nature, whisper of a universe fine tuned for possibility, a cosmic architecture where the slightest variation would render existence impossible. The strength of gravity, the nuclear forces, the mass of the electron, these fundamental numbers appear perfectly calibrated to allow for the formation of stars, planets, and the complex chemistry that leads to life. This precise tuning suggests either an astonishing coincidence or a deeper structure to reality that we have yet to comprehend, a mystery that lies at the heart of our search for meaning in the cosmos. For the searcher, this fine tuning offers both hope and humility. Hope, because it suggests the universe may be inherently biofriendly, with the laws of physics predisposed toward the emergence of complexity and consciousness. Humility, because it reminds us that we are products of this specific cosmic environment, our perception and understanding limited by the very constants that make our existence possible. We search for others with instruments and concepts born of this particular universe, potentially blind to forms of existence beyond our physical paradigm. The fine tuning also suggests a cosmic context for our search. If the universe is indeed structured to permit life, then the emergence of intelligence might be a natural consequence of cosmic evolution. We could be witnessing the universe becoming aware of itself through multiple eyes, multiple minds. Our search for extraterrestrial intelligence then becomes part of a larger process of cosmic self discovery, a way for the universe to explore its own potential through the beings it has generated. This perspective transforms the search from a mere scientific endeavor to something approaching a sacred quest. We are not just looking for company in the void. We are helping the universe fulfill its potential for awareness. Each listening session, each observation becomes a participation in this grand process. The silence we encounter is not empty, but pregnant with possibility, a canvas waiting for the first brushstrokes of connection to appear. The age of the universe provides both opportunity and challenge for the search. With 13.8 billion years of cosmic history, there has been ample time for civilizations to arise, evolve, and potentially disappear. The Milky Way itself formed relatively early in cosmic history, with many stars billions of years older than our Sun. This means that if intelligence is a natural outcome of cosmic evolution, there could be civilizations that achieved technological capability long before Earth even formed. The challenge lies in the timing. Civilizations may bloom and fade like flowers in a field, their detectable phases brief compared to cosmic timescales. The window for mutual detection between two civilizations must overlap not just in space, but in time. We might be listening for signals from civilizations that expired millions of years ago, or we might be broadcasting to civilizations that will not develop the capability to hear us for millions of years to come. This temporal coordination problem adds another layer of complexity to the search. Yet the universe's great age also offers hope through persistence. Some civilizations might achieve longevity, surviving for millions or even billions of years. Such enduring cultures would be far more likely to be detected, as their detectable phase would span enormous stretches of time. Finding even one such civilization would demonstrate that long term survival is possible, offering hope for our own future. Their existence would suggest that technological species can navigate the challenges that threaten their infancy. The search, therefore, becomes a test of cosmic sustainability. Are technological civilizations inherently self destructive, or can they learn to live in balance with their worlds and themselves? The answer may lie in the silence or in a signal yet to be received. Either way, the universe's great age gives the experiment time to run, allowing the story of intelligence to unfold across the galaxy in its own time, at its own pace. The information theory of the universe suggests that reality may be fundamentally computational, with the cosmos operating as a vast information processing system. From this perspective, the search for extraterrestrial intelligence becomes a search for information processing systems beyond Earth, for patterns of complexity that indicate the presence of mind. This view expands the concept of intelligence beyond biological beings to include any system that processes information in sophisticated ways. This computational perspective offers new ways to search. Instead of just looking for radio signals or atmospheric biosignatures, we might look for evidence of information processing on planetary or stellar scales. The waste heat from computation, the organization of matter into complex structures, or even the manipulation of space-time itself could potentially be detectable signs of advanced intelligence. The search becomes a hunt for cosmic informatics, for evidence that the universe contains more than just natural information processing. The concept of a planetary brain emerges from this thinking, the idea that a civilization might eventually integrate with its planet's systems so completely that the planet itself becomes a conscious entity. Such a being might communicate in ways we cannot yet imagine, using the planet's magnetic field, seismic activity, or even its orbital dynamics as means of expression. Detecting such intelligence would require us to think far beyond our current paradigms of communication and technology. This expanded view of intelligence also suggests that we might be surrounded by consciousness in forms we fail to recognize. The solar system itself might contain ancient informational systems left by previous civilizations or natural systems that have evolved their own forms of awareness. The search for extraterrestrial intelligence becomes not just about finding others like us, but about learning to perceive the full spectrum of consciousness that might exist in the universe. The interstellar medium itself might hold messages we have overlooked. Rather than directed signals, an advanced civilization might use the space between stars as a storage medium, encoding information in the polarization of light across vast distances or in the subtle patterns of cosmic dust distribution. These would be messages not meant for quick conversation, but for long-term preservation, time capsules waiting for someone with the right technology to read them. The concept of galactic archaeology takes on new meaning in this context. We might search for artifacts of ancient civilizations not on planetary surfaces, but in the orbital dynamics of star systems, in the unusual arrangements of asteroids or comets that suggest intelligent design. A civilization that has mastered its solar system might rearrange matter for purposes beyond our understanding, creating structures that would be visible across light years, but that we would need to learn to recognize as artificial. The possibility of dormant intelligence also merits consideration. A civilization facing existential threats might choose to encode its essence in radiation resistant formats and broadcast it into space, hoping that some future intelligence might reconstruct it. Or they might create self replicating probes programmed to awaken under specific conditions, spreading throughout the galaxy as silent witnesses waiting for the right moment to reactivate. The galaxy could be filled with such sleeping memories. These possibilities suggest that our current search methods, while valuable, might be looking for the wrong things in the wrong ways. The great silence might not indicate absence, but rather a failure of imagination on our part. As we develop new ways of thinking about information, communication, and intelligence, we may discover that the cosmos has been speaking to us all along, but in a language we are only beginning to learn to hear. The evolutionary path to intelligence may be more diverse than we imagine. On Earth, intelligence emerged through particular evolutionary pressures and historical accidents, but other worlds might develop consciousness through completely different pathways. Octopuses demonstrate a distributed intelligence, unlike our centralized brain model. Social insects show collective intelligence emerging from simple individual behaviors. These examples suggest that intelligence can take many forms, even on one planet. The conditions for intelligence might vary widely across worlds. A planet with a stable climate over billions of years might develop intelligence slowly and gradually. A world with frequent extinction events might see intelligence emerge rapidly as an adaptation to change. High gravity worlds might favor different body plans and sensory modalities than low gravity environments. Each world's unique history and conditions would shape the intelligence that emerges there. The communication methods of such intelligences would likely reflect their evolutionary history. Species that evolved in dark environments might use sonar or electrical fields for communication. Aquatic species might use complex water vibrations. Species that perceive different ranges of the electromagnetic spectrum might naturally develop optical or radio communication. Our search assumptions, based on human senses and technology, might cause us to miss signals that are obvious to other types of minds. This diversity suggests that the galaxy could be rich with intelligence, but in forms so alien that we don't recognize them as such. The challenge is not just to develop better technology for detection, but to develop better conceptual frameworks for understanding what intelligence might look like in different environments. The search must become increasingly interdisciplinary, drawing on biology, psychology, computer science, and other fields to expand our notion of what we're searching for. The energy requirements for interstellar communication present both a challenge and a potential signature. To send a detectable signal across light years requires tremendous power, likely far beyond what our civilization currently generates. This suggests that any civilization we detect will either be much more advanced than us or will be making an extraordinary effort to communicate. The energy signature of such transmission attempts might itself be detectable even if the message content is not. Alternatively, a sufficiently advanced civilization might have solved the energy problem through means we cannot yet imagine. They might tap into zero-point energy, harness the power of black holes, or utilize other physics beyond our current understanding. The detection of such energy signatures, unexplained power emissions from star systems, could be another way to find evidence of intelligence without needing to decode messages. The energy perspective also raises questions about sustainability. A civilization that expands its energy consumption without limit would eventually become visible through its waste heat, potentially detectable as an infrared anomaly around its star. The absence of such signatures might indicate that advanced civilizations learn to live within their energy means, or that they develop ways to use energy so efficiently that they leave minimal thermal footprint. This energy calculus affects our own search strategy. How much energy should we devote to listening versus transmitting? Is it reasonable to use significant planetary resources for a search that might not yield results for centuries or millennia? These questions force us to think long term about our place in the cosmos and what kind of civilization we want to become. The search for others becomes intertwined with questions about our own values and priorities. The psychological preparation for discovery involves considering not just the content of a message, but its potential effects on human culture. History shows that encounters between previously isolated human cultures often had dramatic and sometimes destructive consequences. While we hope that contact with extraterrestrial intelligence would be beneficial, we must prepare for the possibility that it could be disruptive to our societies, economies, and belief systems. The discovery might trigger what psychologists call cosmic shock, a profound disorientation resulting from the realization that we are not the center of the universe, that there are others older, wiser, or more powerful than ourselves. This could lead to both positive and negative reactions, a new sense of cosmic unity or a crisis of meaning. Preparing for this psychological adjustment is as important as the technical aspects of the search. The potential for misinformation and manipulation is another concern. How would we verify that a message is truly from an extraterrestrial intelligence and not an elaborate hoax? How would we prevent governments or corporations from controlling access to the message or its interpretation? Establishing transparent, international protocols for verification and dissemination is crucial to ensuring that the benefits of discovery are shared by all humanity. Perhaps most importantly, we must prepare for the possibility that the message might be incomprehensible to us. It might contain concepts so advanced that we lack the framework to understand them, or it might be intended for a different type of consciousness altogether. Learning to live with mystery, with the knowledge that there are things beyond our current understanding, might be the ultimate psychological preparation for contact. The evolutionary implications of contact could be profound. Learning about another evolutionary path to intelligence could revolutionize our understanding of biology, consciousness, and technology. We might discover entirely new principles of organization, new ways of processing information, or new approaches to solving problems that have challenged us for centuries. This knowledge could accelerate our own development in unpredictable ways. The exchange of biological information could be particularly transformative. Learning about alien biochemistry might lead to new medical treatments, new materials, or new energy sources. It could also help us understand the fundamental principles of life itself, whether all life shares common features or whether completely different biochemistries are possible. This knowledge would fundamentally change our place in the universe. However, such exchanges would also carry risks. Alien biological material could potentially be dangerous to Earth's ecosystems or ours to theirs. The history of invasive species on Earth shows how introducing foreign organisms can have unintended consequences. Any exchange of biological information would need to be handled with extreme caution, following strict protocols to prevent accidental harm. The long term evolutionary impact might be the gradual convergence of intelligences. As we learn from each other, our technologies, philosophies, and even biologies might begin to reflect this exchange. Over millennia, this could lead to the emergence of a galactic culture that incorporates elements from multiple evolutionary paths. The search for extraterrestrial intelligence thus becomes the first step in a much longer evolutionary journey. The ethical dimensions of the search extend beyond humanity to consider our responsibilities toward other intelligences we might discover. If we find a less advanced civilization, do we have an obligation to protect them from outside interference? Should we observe silently or attempt to make contact? These questions mirror ethical debates about human interactions with uncontacted tribes but on a cosmic scale. If we discover a more advanced civilization, different ethical questions emerge. What rights would we have to their knowledge or technology? Would it be ethical to ask for help with our problems, or would that make us dependent? How do we ensure that any relationship is based on mutual respect rather than exploitation? These questions require us to think about cosmic ethics in ways we have never had to before. The ethics of our own broadcasting also need consideration. Are we right to announce our presence to the galaxy without knowing who might be listening? Some argue that it is arrogant to assume others would be interested in us, while others worry that it might be dangerous to reveal our location. There are no easy answers, but the question deserves serious ethical consideration as our transmissions become increasingly powerful. Ultimately, the search forces us to expand our ethical circle beyond Earth, to consider that we might have moral responsibilities to beings not of our world. This expansion of ethics is perhaps one of the most important benefits of the search, even if we never find anyone. It prepares us to think as a planetary species, to consider our actions in a cosmic context, and to approach the universe with both curiosity and respect. As our contemplation reaches its gentle conclusion, we return to the essential mystery that has guided humanity's gaze upward for millennia. The search for extraterrestrial intelligence represents some of our best qualities: our curiosity, our perseverance, our hope for connection, our willingness to think in cosmic terms. It is a project that spans generations, a question we keep alive for those who will come after us. The silence, for now, remains unbroken, but it is a fertile silence, filled with potential and wonder. Each night of listening adds to our knowledge, even if only by telling us where not to look. Each new telescope, each new algorithm, each new generation of scientists brings us closer to the possibility of an answer. The search itself becomes a kind of conversation with the universe, a way of saying we are here and we are listening. Whether we find others or not, the search changes us. It expands our perspective, humbles our pretensions, and connects us to the cosmos in a deeper way. It reminds us that we are part of something vast and mysterious, and that our story is still being written. The question of whether we are alone is ultimately a question about the nature of reality itself and our place in it. So the search continues, a quiet persistence against the great silence. The telescopes keep listening, the scientists keep analyzing, and humanity keeps wondering. The answer may come tomorrow, or in 1,000 years, or never. But the question is too important not to ask, the possibility too profound to ignore. And so we listen, patiently, hopefully, to the whispers of the cosmos. The silence of the cosmos speaks in a language of its own, a quiet poetry written in the spaces between stars. Each unanswered signal is not a void, but a stanza in an epic poem of existence, a measured breath in the universe's great meditation. This silence holds more meaning than we might initially perceive, containing within it the potential for countless stories yet untold, countless voices yet to join the cosmic chorus. To listen to this silence is to participate in a form of deep cosmic listening, an attentiveness to what is not said as much as to what is. In many spiritual traditions, silence is not empty, but full, a presence rather than absence. The cosmic silence might be understood similarly, not as evidence of loneliness, but as a space of possibility. It is the blank page before the writing, the quiet room before the conversation begins. This perspective does not discourage the search, but enriches it, adding depth and meaning to the act of listening itself. We listen not just for answers, but to participate in the great quiet of the universe. The quality of this silence varies across the electromagnetic spectrum. In some frequencies, the universe buzzes with natural activity, the microwave background radiation, the pulsing of quasars, the thermal noise of dust clouds. In other bands, particularly those most suited for communication, the universe remains remarkably quiet. This patchwork of noise and silence creates a cosmic landscape of sound and stillness, with islands of natural radio chatter separated by seas of perfect quiet where an artificial signal would stand out clearly. Learning to appreciate this cosmic soundscape is part of the searcher's training. Like naturalists learning to identify bird calls in a forest, SETI scientists learn to recognize the signature of pulsars, the whisper of interstellar hydrogen, and the crackle of solar flares. This attunement to the natural radio sky is necessary groundwork, the learning of a new sensory language. Only by understanding the natural sounds can we hope to recognize the artificial ones, the notes that don't belong to nature's score. The architecture of silence extends beyond mere absence of sound to encompass the very structure of cosmic evolution. The universe has been unfolding for billions of years, following physical laws that have allowed increasing complexity to emerge from initial simplicity. Stars formed, then planets, then in at least one case, life and consciousness. This architectural progression suggests a universe that builds toward complexity, that tends toward the emergence of mind. The silence we experience may simply reflect the careful, gradual nature of this construction. Within this architectural framework, each civilization might represent a kind of flowering, a peak of complexity within its local region of space-time. The distances between these flowers of intelligence would be vast, reflecting the careful spacing of the universe's garden. Communication between them would be difficult not by accident but by design, the natural consequence of a cosmos that values both connection and independence, both community and solitude. The silence becomes a protective boundary, allowing each civilization to develop according to its own nature. The timing of these flowerings also follows cosmic architecture. Some stars formed early and might have hosted civilizations that rose and fell billions of years ago. Others, like our Sun, formed later and are only now potentially giving rise to technological species. Still, other stars have yet to form or will form in the distant future. This staggered schedule means that at any given moment, the number of simultaneously communicating civilizations might be small, their signals separated by both space and time. Understanding this architectural perspective helps reframe the search. We are not listening in a random void, but in a carefully structured universe with a deep history and a potentially meaningful future. The silence is part of that structure, not an anomaly to be overcome, but a feature to be understood. Our listening becomes a way of learning about the universe's design principles, about how it spaces and times the emergence of intelligence across the cosmic expanse. The technology of listening has evolved in harmony with our growing understanding of the cosmos. Early radio telescopes were relatively simple devices capable of listening to one frequency at a time with limited sensitivity. Today's instruments are marvels of engineering, able to monitor billions of channels simultaneously, process immense volumes of data in real time, and distinguish between natural and artificial signals with increasing sophistication. This technological evolution mirrors our conceptual evolution in understanding what we might be searching for. The development of signal processing algorithms represents a quiet revolution in the search. Early searches looked for strong, obvious signals, the equivalent of someone shouting across a quiet room. Modern approaches can detect much subtler patterns, the equivalent of recognizing a familiar melody played softly in a noisy restaurant. These algorithms use techniques from information theory, machine learning, and even cryptography to find meaning in apparent randomness, order, in the midst of chaos. The infrastructure supporting the search has also grown increasingly sophisticated. Distributed computing projects allow millions of people to participate using their personal computers. Data from multiple telescopes can be combined to improve sensitivity and verify potential signals. International collaborations share resources and expertise, creating a global network of listening posts. This infrastructure represents a remarkable achievement of human cooperation, all directed toward answering a single, profound question. Looking forward, quantum technologies promise another leap in capability. Quantum sensors could detect incredibly faint signals. Quantum computers could process data in fundamentally new ways, potentially recognizing patterns that classical computers would miss. Quantum communication might even allow us to detect forms of information transfer that are currently invisible to us. The ongoing technological evolution ensures that our ability to listen will continue to improve, potentially bringing us closer to detection even as the silence persists. The psychology of purpose is in the face of negative results reveals much about human nature. Why do we continue to search when year after year, decade after decade, the silence remains unbroken? The answer lies in the human capacity for hope, for curiosity, for the ability to find meaning in the search itself rather than only in its successful conclusion. This psychological orientation represents a mature approach to scientific inquiry, one that values questions as much as answers. The searchers develop what might be called cosmic patience, an ability to think in time frames that span generations rather than individual lifetimes. They understand that their work may not bear fruit in their own careers, but that it contributes to a larger project that will continue long after they are gone. This perspective is increasingly rare in a world focused on short term results and immediate gratification, making the SETI endeavor psychologically distinctive and valuable. The search also cultivates what astronomer Carl Sagan called the baloney detection kit, a set of cognitive tools for distinguishing between valid claims and wishful thinking. In a field where the desire for discovery is strong, the discipline of skepticism becomes particularly important. Each potential signal must be subjected to rigorous testing. Each exciting possibility must be examined with cold objectivity. This balance between hope and skepticism represents a psychological achievement in itself. For the broader public, following the search provides practice in managing expectations about scientific progress. Science is often portrayed as a series of dramatic breakthroughs, but most research involves slow, incremental accumulation of knowledge with many dead ends and false starts. The SETI enterprise models this reality openly, helping the public understand how science actually works, not as a straight path to discovery, but as a meandering journey of exploration. The evolutionary context of intelligence suggests that our cognitive capacities emerged through specific adaptive pressures on Earth. Our pattern recognition, our curiosity, our tendency to attribute agency to natural phenomena, all these traits helped our ancestors survive in a dangerous world. But these same traits might shape our expectations about extraterrestrial intelligence in ways that don't match reality. We might be looking for patterns that don't exist, or missing patterns that do exist, but don't match our expectations. Our concept of intelligence itself is culturally and evolutionarily specific. We value certain cognitive abilities, abstract reasoning, technological innovation, scientific curiosity, that were adaptive in our evolutionary history. But other paths might lead to different kinds of intelligence. Intuitive understanding of complex systems, emotional depth, artistic expression, or forms of consciousness we cannot imagine. Our search parameters might be too narrow, based on a limited understanding of what intelligence can be. The timing of intelligence's emergence on Earth might also be unusual. It took billions of years of evolutionary experimentation before technological intelligence appeared. On other worlds, this process might happen much faster, or much slower, or might not happen at all. The conditions that favored the emergence of intelligence on Earth, a stable climate, a large moon to stabilize rotation, plate tectonics to recycle nutrients, might be rare in the universe, making technological intelligence correspondingly rare. Despite these cautionary notes, the evolutionary perspective also offers hope. Evolution tends to fill available niches, and the cognitive niche, the ability to understand and manipulate the environment through intelligence, is a powerful one. On worlds where life emerges, evolution might frequently stumble upon intelligence as a solution to survival challenges, even if the specific form that intelligence takes varies widely from world to world. The universe might be rich with minds, even if few of them match our particular expectations. The ecological dimension of intelligence suggests that technological civilizations might face similar challenges regardless of their biological basis. The transition from using energy flows within ecosystems to harnessing stored energy sources often marks a turning point in technological development. This transition brings power but also responsibility. The need to manage waste products, avoid resource depletion, and maintain ecological balance. These challenges might be universal for technological species. The solution to these ecological challenges might determine a civilization's longevity and therefore its detectability. Civilizations that learn to live in sustainable balance with their planets might persist for long periods, increasing the chance of detection. Those that fail to solve these problems might collapse quickly, leaving only brief detectable signatures. The Great Silence might therefore reflect not the absence of intelligence, but the difficulty of achieving long-term ecological sustainability. This ecological perspective suggests new ways to search for healthy intelligence. Instead of looking for signals, we might look for evidence of ecological engineering, planets with atmospheric compositions that suggest careful management rather than natural balance. These would be worlds where intelligence has learned to act as a responsible steward rather than a disruptive force, where technology serves to maintain rather than destroy ecological harmony. For humanity, this ecological dimension adds urgency to our own situation. Our civilization is currently undergoing the difficult transition to sustainability. The search for extraterrestrial intelligence becomes, in this light, a search for hope, evidence that other civilizations have successfully navigated this transition and achieved long term stability. Their existence would show that our ecological challenges are solvable, that intelligence can indeed learn to live in balance with its world. The narrative quality of the search gives it a distinctive place in human culture. Unlike most scientific endeavors, SETI has a built in story arc, the long quest, the potential for dramatic discovery, the transformative implications of success. This narrative structure helps sustain public interest and support even in the absence of concrete results. The story itself has value, independent of its outcome. As a reflection of human aspirations and curiosities, the SETI story also serves as a counter narrative to more pessimistic visions of humanity's future. In a world often focused on conflict, environmental crisis, and short term thinking, the search represents a long term, cooperative, peaceful project aimed at answering a fundamental question about our place in the cosmos. It offers a vision of humanity at its best: curious, cooperative, persistent, and forward looking. The potential climax of this story, first contact, has been imagined in countless ways in science fiction, from peaceful exchange to destructive invasion. These imagined scenarios serve as cultural rehearsals, allowing us to explore the implications of contact before it happens. They help prepare us psychologically for the possibility giving us a repertoire of responses to draw upon if contact ever occurs. Yet the actual story of contact would likely be different from any fictional portrayal. It might be more gradual, more ambiguous, more puzzling than dramatic. The narrative might unfold over decades rather than days, with slow decipherment and careful interpretation rather than immediate understanding. The true story of contact would likely be more interesting, more complex, and more human than any fictional version, reflecting the messy, uncertain, and fascinating nature of reality itself. The educational value of the search extends far beyond its direct scientific goals. SETI provides a compelling context for teaching about astronomy, physics, biology, and many other fields. Students naturally engage with the question of extraterrestrial life, making it an effective hook for learning about more challenging concepts. The search makes science exciting and relevant, showing how different disciplines connect to address a profound question. The search also teaches important lessons about the nature of science itself. It demonstrates how scientific inquiry works, asking clear questions, developing testable hypotheses, building appropriate instruments, analyzing data rigorously, and following the evidence wherever it leads. It shows science as a process rather than just a collection of facts, highlighting the values of curiosity, skepticism, and persistence that drive scientific progress. For the broader public, following the search provides a model for thinking about uncertainty and the unknown. In an increasingly complex world, the ability to live with unanswered questions, to avoid premature conclusions, and to update beliefs based on new evidence is increasingly important. The SETI enterprise, with its decades of careful work without definitive answers, models this thoughtful approach to uncertainty. The international and cooperative nature of the search also offers educational value. Scientists from many countries work together, sharing data and resources across national boundaries. This collaboration provides a positive model of international cooperation aimed at common human goals rather than national interests. In a world often divided by conflict, this aspect of the search reminds us of what humanity can achieve when we work together. The philosophical implications of the search continue to unfold as our understanding evolves. Each new discovery in astronomy and biology refines our thinking about the possibility of extraterrestrial intelligence. The discovery of exoplanets, for instance, has transformed the question from "Are there other worlds?" to "What are these other worlds like?" This shift has deep philosophical implications, moving the discussion from abstract possibility to concrete probability. The search also forces us to confront fundamental questions about the nature of mind and consciousness. If we discover other intelligences, we will have to expand our understanding of what consciousness can be, what forms it can take, and how it might differ from our own experience. Even the continued absence of detection pushes us to think more deeply about why technological intelligence might be rare and what that might say about the nature of intelligence itself. The temporal scale of the search raises philosophical questions about humanity's place in cosmic time. Our civilization is a recent development in a universe billions of years old, and we may be temporary residents in a cosmos that will continue for billions more years. This perspective can be both humbling and liberating, encouraging us to think beyond short term concerns and consider our role in a much larger story. Ultimately, the search serves as a mirror reflecting humanity back to itself. The questions we ask about others reveal much about our own hopes, fears, and values. The ways we imagine extraterrestrial intelligence tell us about how we see ourselves. The persistence of our search speaks to our deep need for connection and meaning. In looking outward, we inevitably look inward, discovering ourselves through the act of searching for others. As our contemplation draws toward its gentle conclusion, we return to the essential mystery that has guided this journey. The search for extraterrestrial intelligence represents one of humanity's most profound and enduring questions, an inquiry that spans scientific disciplines, philosophical traditions, and cultural expressions. It is a question that has persisted for centuries and will likely continue for centuries more, a constant companion to our species as we explore the cosmos. The silence we have encountered thus far is not evidence of failure, but an invitation to deeper listening. Each negative result narrows the possibilities, guiding our search toward more promising avenues. Each technological improvement increases our sensitivity, allowing us to hear whispers that were previously inaudible. Each conceptual breakthrough expands our imagination, helping us recognize forms of intelligence we might previously have overlooked. The value of the search lies not only in its potential success, but in its ongoing practice. The act of listening itself cultivates valuable qualities: patience, curiosity, humility, and wonder. It encourages international cooperation, technological innovation, and philosophical reflection. It inspires new generations to study science and look upward with hope and curiosity. These benefits accumulate regardless of whether we ever detect a signal, so the search continues. A quiet persistence against the great silence. The telescopes keep listening, the scientists keep analyzing, and humanity keeps wondering. The answer may come tomorrow, or in 1,000 years, or never. But the question is too important not to ask, the possibility too profound to ignore. And so we listen, patiently, hopefully, to the whispers of the cosmos. The poetry of cosmic distances unfolds in measures of light and time, each astronomical unit a verse in the epic of separation between worlds. These immense gaps are not mere emptiness, but a fundamental aspect of the universe's architecture, creating natural sanctuaries where intelligence can develop in isolation before potentially reaching out to others. The silence we perceive is in part a function of this careful spacing, this cosmic zoning that allows for independent evolution across the galaxy. Within these distances, light becomes both messenger and historian, carrying information from the deep past to our present instruments. When we look at a star 1,000 light years away, we see it not as it is now, but as it was a millennium ago. Any signal we might detect would be similarly ancient, a message from a civilization's history rather than its present moment. This temporal dimension adds layers of complexity to communication, turning potential exchanges into conversations across time as well as space. The scale of these distances also shapes the nature of any potential contact. The speed of light, while immense by human standards, becomes a limiting factor when crossing interstellar space. This constraint means that conversation in the familiar sense, rapid back and forth exchange, is impossible across even modest cosmic distances. Communication would necessarily become more deliberate, more considered, with each message crafted to stand on its own as a meaningful statement rather than part of a quick dialogue. This distancing effect might be purposeful in cosmic terms, a natural mechanism that prevents premature interaction between civilizations at different stages of development. The vast spans between stars ensure that any contact occurs only when a civilization has achieved sufficient technological maturity to bridge the gap. The silence thus becomes a protective barrier, a cosmic quarantine that allows each world to develop at its own pace, according to its own unique evolutionary path. The mathematics of possibility weaves through the search like a golden thread, connecting hard data to hopeful speculation. Probability theory gives us tools to estimate the likelihood of various outcomes, from the number of potential civilizations to the chance of detecting a signal within a given time frame. These calculations are necessarily imprecise, based on unknown variables and simplifying assumptions, yet they provide a framework for thinking about the search in quantitative terms. The statistics of signal detection present their own fascinating challenges. With millions of frequencies to monitor and countless sky directions to search, the problem becomes one of efficient sampling rather than comprehensive coverage. Statisticians develop sophisticated algorithms to optimize this sampling to maximize the chance of detection given limited resources. These methods represent a marriage of mathematics and astronomy, of abstract theory applied to concrete observational challenges. The concept of statistical significance takes on special importance in a field where the potential for false positives is high. A signal that appears promising must be evaluated not just on its own merits, but against the probability of such a signal occurring by chance. This statistical rigor acts as a necessary counterbalance to the natural excitement that accompanies any potential discovery, ensuring that claims are backed by solid mathematical foundations rather than wishful thinking. As the search continues, Bayesian statistics offer a powerful framework for updating our beliefs based on new evidence. Each observation, whether it yields a detection or continued silence, slightly adjusts the probability estimates for various scenarios. This mathematical approach allows the search to evolve rationally, incorporating new data into an ever refining understanding of the likelihood that we are not alone in the universe. The artistry of the search manifests in its creative approaches to problem solving, its willingness to imagine new possibilities and develop novel methods to test them. Like artists working in a medium of mathematics and technology, SETI researchers combine rigorous science with creative thinking, using imagination to guide where and how to search for signs of other minds. This creative aspect extends to the interpretation of potential signal. Should a candidate signal be detected, researchers would need to exercise considerable creativity in attempting to decode its meaning. They might look for mathematical patterns, universal constants, or other potentially shared reference points that could serve as a foundation for understanding. This decoding process would be part science, part art, a creative act of interpretation across unimaginable cultural distances. The presentation of the search to the public also requires artistic sensibility. Complex scientific concepts must be translated into accessible language, technical challenges explained in engaging ways, and the profound implications of potential discovery communicated with appropriate wonder and gravity. Scientists working in SETI often become skilled communicators, learning to share their work in ways that capture the public imagination while maintaining scientific integrity. Even the design of messages we might send into space represents a creative challenge. Crafting a communication that could be understood by a completely alien intelligence requires thinking beyond human cultural specificities to more universal concepts, mathematics, physics, fundamental aspects of chemistry, and biology. This effort to create something simultaneously specific enough to be meaningful and general enough to be widely understandable is essentially a creative act, a work of art intended for an unknown audience. The sociology of the search reveals much about how humanity organizes itself to address profound questions. SETI represents a unique scientific subculture with its own values, traditions, and ways of working. Researchers in this field develop particular psychological attributes: patience, tolerance for uncertainty, long term thinking, that set them apart from scientists working in fields with more immediate results. This sociological perspective also helps us understand how a detection might be handled socially. The protocols developed for post detection represent a remarkable achievement in international cooperation and forward thinking. They outline processes for verification, notification, and response that attempt to balance scientific openness with responsible disclosure. These protocols show humanity at its most thoughtful, attempting to plan for an event that would affect all people regardless of nationality or culture. The public engagement with SETI offers fascinating sociological insights as well. The mix of serious scientific interest, popular fascination, and occasional skepticism reveals how different segments of society relate to science and to big questions about humanity's place in the universe. This engagement serves as a barometer of public attitudes towards science, technology, and the unknown. Looking forward, the sociology of contact presents intriguing questions. How would different cultures respond to the discovery of extraterrestrial intelligence? How would existing social structures and institutions adapt? Would the discovery unite humanity or create new divisions? These sociological questions are as important as the technical ones, reminding us that the search is ultimately about people and how we might relate to others unlike ourselves. The ecology of intelligence considers how minds interact with their environments, how cognitive beings shape and are shaped by their worlds. This perspective suggests that technological civilizations might follow predictable developmental pathways based on the ecological constraints and opportunities of their home planets. Understanding these potential pathways could help us better know where and how to search for signs of other intelligence. The concept of ecological footprint takes on cosmic significance in this context. A civilization's energy usage, resource consumption, and waste production might create detectable signatures across interstellar distances. Searching for these signatures, unusual atmospheric compositions, excess heat emissions, or other indicators of planetary scale engineering, represents an alternative approach to traditional SETI, one based on ecological rather than communicative evidence. This ecological view also suggests that sustainability might be a common challenge for technological civilizations. The transition from planet bound species to sustainable cosmic civilization might represent a critical developmental phase, one that determines whether a species persists long enough to become detectable across interstellar distances. The Great Silence might indicate that this transition is difficult to achieve, that many civilizations fail to navigate this ecological bottleneck successfully. For humanity, this ecological perspective adds urgency to our own sustainability efforts. Our ability to solve ecological problems on Earth might determine not just our own survival, but our ability to eventually join what might be a community of cosmic civilizations. The search for others becomes intertwined with our own ecological responsibility, connecting cosmic questions to practical earthly concerns in profound ways. The epistemology of the search concerns how we know what we know, and how we might come to know things beyond our current understanding. SETI pushes at the boundaries of knowledge, forcing us to consider how we would recognize and understand intelligence radically different from our own. This epistemological challenge is perhaps the most profound aspect of the search, touching on fundamental questions about the nature of knowledge itself. The problem of other minds, familiar from philosophy, takes on concrete form in SETI. How would we recognize the presence of another conscious intelligence based solely on its electromagnetic emissions or other remote signatures? What criteria would we use to distinguish intelligent signals from natural phenomena? These questions force us to think carefully about what intelligence is and how it manifests in the world. The potential for encountering intelligence, far more advanced than our own, presents additional epistemological challenges. How would we understand concepts or technologies far beyond our current comprehension? The experience might be similar to an ancient human trying to understand modern physics. The fundamental concepts might be so advanced that we lack even the framework to begin understanding. This humbling possibility reminds us of the limits of our current knowledge. Despite these challenges, the search continues, driven by the belief that knowledge is possible, that understanding can bridge even cosmic distances. This epistemological optimism, the belief that we can come to know the unknown, represents one of the most admirable aspects of the human spirit. It is this belief that sustains the search through decades of silence, this faith that the universe is ultimately knowable and that we are capable of knowing it. The aesthetics of the cosmos infuse the search with a sense of beauty and wonder that complements its scientific rigor. The mathematics underlying signal processing has its own elegance, the engineering of telescopes, its own grace, the architecture of search algorithms, its own beauty. This aesthetic dimension reminds us that science is not merely technical, but can be pursued with artistry and appreciation for the beautiful patterns underlying reality. The experience of working in SETI often involves moments of profound aesthetic appreciation, starlight collected and analyzed, the silent beauty of mathematics applied to cosmic questions, the elegant simplicity of a well-designed experiment. These aesthetic experiences provide their own reward, separate from the practical results of the search. They represent encounters with beauty that sustain researchers through long years without dramatic discovery. The potential messages we might receive could themselves have aesthetic dimensions. An advanced civilization might communicate not just information, but beauty, mathematical harmonies, artistic patterns, or other expressions of cosmic aesthetics. The ability to appreciate such expressions might be an important aspect of interstellar communication, a shared capacity for recognizing beauty that transcends biological differences. This aesthetic perspective also suggests that the search itself, regardless of its outcome, adds beauty to human experience. The very act of listening to the cosmos, of dedicating resources to wondering about other minds, represents a beautiful aspect of human nature. It speaks to our capacity for curiosity, for wonder, for reaching beyond practical concerns to ask profound questions about our place in the universe. This capacity is itself a thing of beauty, worth cultivating for its own sake. The ethics of cosmic stewardship emerge from considering humanity's potential role in a populated galaxy. If we are alone, we bear unique responsibility for nurturing and protecting life and intelligence in our corner of the universe. If we are not alone, we must consider our responsibilities toward other beings and how to interact with them ethically. Both possibilities carry profound ethical implications that deserve careful consideration. This ethical dimension extends to how we conduct the search itself. The choices about where to search, what methods to use, and how to handle potential discoveries all involve ethical considerations. The potential risks of active SETI must be balanced against the scientific benefits. The allocation of resources to SETI rather than other scientific or social needs represents an ethical choice about what knowledge we value most as a species. Looking forward, the ethics of space exploration become increasingly important as we develop capabilities to explore and potentially alter. We must consider our responsibilities toward any life we might find, however simple or complex. The principles we develop for interacting with extraterrestrial life might eventually inform how we treat each other and our own planet, creating ethical feedback loops that improve life on Earth, even as we look beyond it. The search for extraterrestrial intelligence thus becomes not just a scientific endeavor, but an ethical practice, a way of developing our moral capacities in preparation for potential future relationships with other beings. It encourages us to think beyond narrow self interest, to consider our responsibilities toward other possible minds, to practice the ethical maturity that might one day be required of a species that takes its place in a cosmic community. The psychology of wonder sustains the search through decades of negative results, providing emotional fuel for a journey that offers no guarantee of destination. Wonder, that mixture of curiosity, awe, and delight in the face of the mysterious, keeps researchers engaged with the fundamental questions, even when immediate practical rewards are absent. This capacity for wonder represents a valuable human trait worth cultivating for its own sake. Wonder also serves an important cognitive function in the search. It opens the mind to possibilities beyond conventional thinking, encouraging creative approaches to problem solving and willingness to consider unconventional ideas. The best SETI researchers combine rigorous skepticism with open minded wonder, using each to balance the other in their approach to the search. For the public, following the search provides an opportunity to exercise their own capacity for wonder. In a world often focused on practical concerns and immediate problems. SETI offers a connection to something larger, a chance to contemplate profound questions about existence and our place in the cosmos. This exercise of wonder provides its own benefits, enriching human experience, regardless of the search's ultimate outcome. The practice of wonder might also be important preparation for potential contact. Should we ever detect a signal from another intelligence, the ability to respond with wonder rather than fear, with curiosity rather than defensiveness, would be valuable. Cultivating wonder through the search thus serves as psychological preparation for an event that would challenge our understanding of reality and our place in the universe. As our contemplation draws toward its gentle conclusion, we return to the essential mystery that has guided this journey. The search for extraterrestrial intelligence represents one of humanity's most profound and enduring questions, an inquiry that spans scientific disciplines, philosophical traditions, and cultural expressions. It is a question that has persisted for centuries and will likely continue for centuries more, a constant companion to our species as we explore the cosmos. The silence we have encountered thus far is not evidence of failure, but an invitation to deeper listening. Each negative result narrows the possibilities, guiding our search toward more promising avenues. Each technological improvement increases our sensitivity, allowing us to hear whispers that were previously inaudible. Each conceptual breakthrough expands our imagination, helping us recognize forms of intelligence we might previously have overlooked. The value of the search lies not only in its potential success, but in its ongoing practice. The act of listening itself cultivates valuable qualities: patience, curiosity, humility, and wonder. It encourages international cooperation, technological innovation, and philosophical reflection. It inspires new generations to study science and look upward with hope and curiosity. These benefits accumulate regardless of whether we ever detect a signal. So the search continues, a quiet persistence against the great silence. The telescopes keep listening, the scientists keep analyzing, and humanity keeps wondering. The answer may come tomorrow, or in 1,000 years, or never. But the question is too important not to ask, the possibility too profound to ignore. And so we listen, patiently, hopefully, to the whispers of the cosmos. The quiet rhythm of cosmic listening continues through the seasons, a steady pulse of observation that transcends individual human lifetimes. The great radio dishes turn their patient ears to the sky, night after night, year after year, decade after decade. Their movement is governed by the rotation of the earth, the passage of seasons, and the precise mathematics of celestial mechanics. This rhythmic constancy represents humanity's enduring commitment to the question, our willingness to listen even when the silence persists. Within this rhythm, there are smaller patterns: the daily cycle of observations, the weekly analysis of data, the annual conferences where researchers share findings and refine strategies. These patterns create a structure for the search, a regular heartbeat of scientific activity that continues regardless of immediate results. The rhythm itself becomes meaningful, a meditation on patience and persistence in the face of profound mystery. The technological rhythm of the search follows its own cadence, with each generation of instruments building upon the last. New telescopes with greater sensitivity, better signal processing algorithms, more sophisticated methods of distinguishing artificial signals from natural noise. These developments occur in waves, each advancing our capabilities incrementally. The rhythm of technological progress, while sometimes slow, moves steadily forward, increasing our chances of detection with each passing year. This rhythmic persistence represents a noble aspect of human nature, our ability to sustain interest in long-term questions, to maintain curiosity across generations, to keep listening even when answers are not immediately forthcoming. The steady rhythm of the search is itself a message, a testament to our species' capacity for wonder and our refusal to let practical concerns completely overshadow profound questions about our place in the cosmos. The chemistry of life tells a universal story written in the language of atoms and molecules, a narrative that might be repeating throughout the cosmos. The elements essential for life as we know it, carbon, hydrogen, oxygen, nitrogen, are among the most common in the universe, forged in stars and scattered across space by supernovae. This cosmic abundance suggests that the raw materials for life are widely available, waiting only for the right conditions to combine into living systems. The processes that lead from simple molecules to complex life follow principles of chemistry and physics that should operate everywhere. Organic molecules form naturally in space, as evidenced by their detection in meteorites, comets, and interstellar clouds. Amino acids, the building blocks of proteins, have been found in space dust. Sugars, lipids, and other essential components of life appear to form readily under conditions that exist throughout the galaxy. This chemical universality suggests that life itself might be a common cosmic phenomenon. The transition from chemistry to biology, the emergence of self-replicating systems that can evolve, remains mysterious, but laboratory experiments show that many of the steps can occur spontaneously under the right conditions. The fact that life on Earth appears to have begun relatively quickly after the planet cooled suggests that this transition might not be exceptionally difficult given the proper environment. The chemical path to life might be a well-worn road in the universe, traveled by countless planetary systems. When we search for extraterrestrial intelligence, we are ultimately looking for the products of these chemical processes. Beings who, like us, are manifestations of universal chemistry. Creatures of star stuff become conscious. The elements that make our bodies were forged in distant stars, and the same processes have likely created beings on other worlds. This chemical kinship suggests that despite potential vast differences in form and biology, we might share essential commonalities with any intelligence we eventually discover. The physics of communication shapes every aspect of the search, from the choice of frequencies to the design of antennas to the methods of signal processing. The electromagnetic spectrum offers certain windows particularly suited for interstellar communication, frequencies where natural background noise is minimal and where signals can travel vast distances with minimal interference. These quiet bands, particularly around the microwave region, represent the most promising channels for detecting artificial signals. The limitations imposed by physics determine what kinds of communication are possible across interstellar distances. The inverse square law means that signals weaken dramatically with distance, requiring either extremely powerful transmitters or extremely sensitive receivers for detection across light years. The finite speed of light means that any communication will involve significant time delays, making conversation in the human sense impossible across interstellar space. These physical constraints suggest that any successful interstellar communication would likely be quite different from human conversation. Messages would probably be dense with information, designed to be understood without immediate clarification. They might be repeated frequently to increase the chance of detection. They might use mathematical or scientific concepts that are universal rather than culture specific. The physics of the situation would shape the nature of any message we might receive. Despite these constraints, physics also offers hope. The same laws that govern the weakening of signals also allow for extremely sensitive detection methods. Parabolic antennas can focus faint signals, and computers can integrate weak signals over time to pull them out of noise. The physical challenges are significant, but not insurmountable, especially for a technological civilization that has advanced beyond our current capabilities. The biology of potential extraterrestrial life stretches the imagination while remaining grounded in scientific principles. Life on Earth shows incredible diversity, occupying nearly every environment, however extreme, suggesting that life elsewhere might be equally adaptable, from deep sea vents to acidic hot springs to frozen deserts. Earth's extremophiles demonstrate that life can persist in conditions once thought uninhabitable, expanding the range of environments where we might search for life elsewhere. The specific forms that life might take on other worlds could be dramatically different from anything on Earth. Different planetary conditions, varying gravity, atmospheric composition, energy sources would likely produce different solutions to the challenges of survival. Alien life might use different biochemistry, perhaps based on silicon instead of carbon, or using solvents other than water. Their body plans, senses, and ways of interacting with their environment could be unlike anything we know. Intelligence itself might take forms unfamiliar to us. On Earth, intelligence has emerged in various lineages: primates, cetaceans, cephalopods, each with different cognitive strengths and ways of processing information. On other worlds, intelligence might be more collective, distributed among many individuals rather than centered in single beings. It might be more integrated with technology from its inception, or more focused on different aspects of existence than human intelligence. When we search for extraterrestrial intelligence, we are necessarily searching with certain assumptions based on Earth's biology. But we must remain open to the possibility that intelligence elsewhere might be so different that we fail to recognize it initially. The biological diversity of potential intelligence reminds us to keep our search broad, to consider multiple possibilities, and to be prepared for forms of mind that challenge our understanding of what intelligence can be. The mathematics of the cosmos provides a potential universal language for communication across interstellar distances. Mathematics appears to describe the universe with remarkable precision, from the motion of planets to the behavior of subatomic particles. This suggests that mathematical concepts might be shared by any technological civilization, providing a foundation for mutual understanding. Despite biological and cultural differences, simple mathematical concepts, prime numbers, geometric shapes, mathematical constants, might serve as initial greetings, easily recognizable as artificial rather than natural. More complex mathematics could then build on this foundation, allowing for the communication of increasingly sophisticated ideas. Mathematics could provide the framework for sharing information about physics, chemistry, biology, and even aspects of culture that can be quantified or represented mathematically. The language of mathematics might also help overcome the challenges of translation across unimaginable cultural distances. While human languages are deeply tied to specific experiences and environments, mathematics describes relationships and patterns that appear to be universal. A civilization that has developed technology capable of interstellar communication would almost certainly have discovered the same mathematical truths that we have, providing common ground for initial contact. This mathematical perspective influences how we search for signals and how we might design messages to send. Many SETI searches look for patterns that are mathematically significant, repeating sequences, mathematical constants encoded in signal timing, or other numerical patterns that are unlikely to occur naturally. The assumption is that any intentional signal would contain such mathematical signatures, making them distinguishable from the random patterns of nature. The psychology of discovery would involve processing not just the content of a detected signal, but the profound implications of knowing we are not alone. The initial reaction would likely mix excitement, wonder, and apprehension, the thrill of answered curiosity, tempered by uncertainty about what the discovery means for humanity's future. This psychological adjustment would unfold over years as the implications gradually sank in and were processed by individuals and societies. The long term psychological impact might include a new sense of cosmic perspective, a realization that humanity is part of a larger community of intelligence. This could be simultaneously humbling and inspiring. Humbling because we would no longer be unique in our technological capabilities. Inspiring because we would have proof that intelligence can persist and perhaps thrive in the cosmos. This new perspective might help humanity overcome petty divisions and focus on larger goals. There might also be psychological challenges, including anxiety about potential threats or discomfort with the loss of humanity's special status. Some might react with fear or denial, while others might embrace the discovery with uncritical enthusiasm. Managing these varied psychological responses would be an important aspect of integrating the knowledge of extraterrestrial intelligence into human society. Ultimately, the psychological journey would likely mirror other major expansions of human understanding, the realization that Earth is not the center of the universe, that humans evolved from other life forms, that the universe is vastly older and larger than previously imagined. Each of these expansions was initially disruptive, but ultimately enriching, giving humanity a more accurate and awe inspiring view of reality. Discovery of extraterrestrial intelligence would represent the next step in this ongoing expansion of awareness. The sociology of contact would involve managing how information about a discovery is shared and processed across global society. The initial verification would need to be thorough, involving multiple independent confirmations to avoid false alarms. The announcement would need to be handled carefully to prevent panic while maintaining transparency. International protocols provide guidelines, but the actual process would require sensitive judgment and cooperation across cultures and political systems. The long term sociological impacts might include new global institutions focused on interstellar communication and relations. These would need to represent humanity as a whole rather than specific nations or interests. Existing institutions like the United Nations might expand their mandates, or new organizations might form specifically to manage humanity's role as part of a cosmic community. This could accelerate trends toward global cooperation and governance. The discovery might also affect cultural and religious systems worldwide. Some traditions might need to expand their understanding of creation and humanity's place within it. New philosophical movements might emerge focused on cosmic citizenship and interspecies ethics. Art, literature, and music would likely be profoundly influenced, expressing humanity's new understanding of itself in relation to other intelligence. Educational systems would need to incorporate the new reality, teaching children about extraterrestrial intelligence as a fact rather than a speculation. This would require developing new curricula and approaches to science, history, and ethics. The discovery could inspire new generations to study science and pursue space exploration, much as the space race of the 20th century inspired previous generations. 2,000 words. The aesthetics of potential alien communication might include not just information, but beauty, mathematical elegance, artistic patterns, or other expressions that appeal to a sense of aesthetics that might be shared across intelligent species. The concept of beauty often involves patterns, symmetries, and harmonies that have mathematical foundations, suggesting that aesthetic appreciation might be a universal aspect of consciousness. If we receive a message, it might contain elements designed to be appreciated aesthetically as well as understood intellectually. These could include musical patterns expressed mathematically, visual art described algorithmically, or poetic structures based on universal mathematical or scientific concepts. The ability to appreciate such aesthetic elements might be an important aspect of understanding the message fully and connecting with the beings who sent it. Our own messages to the stars might similarly include aesthetic elements reflecting humanity's artistic achievements alongside our scientific knowledge. The Voyager Golden Record, with its sounds and images of Earth, represented an early attempt at this kind of communication. Future messages might be more sophisticated, combining information and beauty in ways that seek to communicate not just facts about humanity, but something of our experience of being human. This aesthetic dimension suggests that the search for extraterrestrial intelligence is not just about finding other minds, but about connecting with other sensibilities, other ways of perceiving and appreciating the universe. The silence we experience now might be filled not just with information, but with beauty waiting to be discovered. Patterns of meaning and appreciation that could enrich human culture as well as expand human knowledge. 2,000 words. Section 7. The ethics of our current search involve questions about how we conduct the search itself, what methods we use, how we allocate resources, how we handle potential discoveries. These ethical considerations become more pressing as our technological capabilities grow and the possibility of detection increases. They require us to think carefully about our responsibilities as we listen for other minds in the cosmos. The potential risks of active SETI, sending messages rather than just listening, generate significant ethical debate. Some argue that announcing our presence could be dangerous if hostile civilizations exist. Others contend that any civilization advanced enough to detect our signals would already be aware of our existence through other means, or that the benefits of contact outweigh the risks. This debate involves weighing uncertain risks against potential rewards, a classic ethical challenge. The allocation of resources to SETI also raises ethical questions, particularly when there are so many pressing needs on Earth. Supporters argue that the search inspires technological innovation, promotes international cooperation, and addresses fundamental human questions that have value in themselves. Critics question whether resources might be better spent on immediate earthly problems. This tension between practical concerns and aspirational goals is a recurring theme in many areas of human endeavor. Looking forward, the ethics of first contact will require careful consideration of how to interact with another civilization responsibly. This includes questions about what information to share, how to avoid cultural contamination, and how to ensure that any relationship is based on mutual respect rather than exploitation. Developing these ethical frameworks in advance, even speculatively, represents an important exercise in cosmic responsibility. As our contemplation draws toward its gentle conclusion, we return to the essential mystery that has guided this journey. The search for extraterrestrial intelligence represents one of humanity's most profound and enduring questions, an inquiry that spans scientific disciplines, philosophical traditions, and cultural expressions. It is a question that has persisted for centuries and will likely continue for centuries more, a constant companion to our species as we explore the cosmos. The silence we have encountered thus far is not evidence of failure, but an invitation to deeper listening. Each negative result narrows the possibilities, guiding our search toward more promising avenues. Each technological improvement increases our sensitivity, allowing us to hear whispers that were previously inaudible. Each conceptual breakthrough expands our imagination, helping us recognize forms of intelligence we might previously have overlooked. The value of the search lies not only in its potential success, but in its ongoing practice. The act of listening itself cultivates valuable qualities: patience, curiosity, humility, and wonder. It encourages international cooperation, technological innovation, and philosophical reflection. It inspires new generations to study science and look upward with hope and curiosity. These benefits accumulate regardless of whether we ever detect a signal. So the search continues, a quiet persistence against the great silence. The telescopes keep listening, the scientists keep analyzing, and humanity keeps wondering. The answer may come tomorrow, or in 1,000 years, or never. But the question is too important not to ask, the possibility too profound to ignore. And so we listen, patiently, hopefully, to the whispers of the cosmos. The cosmic ocean stretches beyond comprehension, its waves of darkness rolling between islands of light, separated by distances that dwarf human imagination. Within this immense aquatic metaphor, each star system becomes an island continent, isolated by voids so vast that travel between them requires crossing abyssal plains where time itself stretches and distorts. The search for other intelligence becomes a form of a cosmic oceanography, mapping currents of radiation and listening for messages carried on electromagnetic tides. The chemistry of this ocean is rich with potential, its waters containing the elements of life, scattered supernovae, and stellar winds. Complex molecules form in the dark molecular clouds that drift between stars like underwater forests, their chemical richness suggesting that the ingredients for life are widely distributed throughout the galactic sea. Planets form within this ocean like pearls around grains of sand, each potentially hosting its own unique ecosystem in the great cosmic deep. The physics of this ocean determines how messages might travel through it. Electromagnetic waves move at light speed, the ultimate velocity limit in this cosmic sea. Gravity creates currents and eddies in space-time itself, bending the paths of both matter and energy. The ocean has its own weather, solar winds, radiation storms, and magnetic fields that can distort or carry signals across the light years. Understanding this marine physics is essential for knowing how to send and receive messages within it. Within this oceanic perspective, the silence we experience might be understood differently. The cosmic ocean may be full of life, but with communication limited by the same factors that limit communication in Earth's oceans: distance, absorption, background noise, and the simple fact that most creatures do not deliberately broadcast messages across the deep. Our listening might be akin to early marine biologists lowering the first hydrophones into the sea, wondering what sounds might emerge from the darkness. The mathematics of infinity haunts the search, both inspiring and humbling in its implications. The universe may be infinite in extent, containing an endless number of stars and planets. In such a cosmos, the probability that life exists elsewhere approaches certainty. There should be countless civilizations scattered across the endless expanse. Yet the same infinity that guarantees their existence also ensures that most are forever beyond our reach, separated by distances so great that not even light can bridge them within the lifetime of the universe. This mathematical reality shapes the search in practical ways. While the universe may be infinite, the observable universe, the portion from which light has had time to reach us, is finite, containing only about 2 trillion galaxies. Within our own galaxy, the number of stars is vast but countable, around 100 billion. The search focuses on this manageable, though still immense number, particularly on the stars closest to us and those most similar to our Sun. The statistics of the search follow from these numbers. Even if technological civilizations are rare, with only one per galaxy on average, there should still be billions in the observable universe, Ed. But if they are short-lived, their signals might overlap only briefly in both space and time. The mathematics of probabilities helps us estimate how many civilizations might be detectable at any given moment, and how long we might need to search to have a reasonable chance of detection. This mathematical perspective helps maintain realistic expectations. The universe is vast, but not infinite in its practical accessibility. The search may require patience spanning generations, and success is never guaranteed. Yet the numbers also provide hope. With so many stars, so many planets, and so many possibilities, the emergence of other intelligence seems almost inevitable. The mathematics points toward a universe that should be teeming with life, even if finding evidence remains challenging. The psychology of the long search requires developing a relationship with uncertainty. Unlike almost any other scientific endeavor, most research fields offer periodic breakthroughs, incremental progress, or at least clear negative results. SETI offers decades of silence, with no certainty that the silence will ever be broken. Maintaining motivation under these conditions requires a particular psychological orientation, one that finds meaning in the search itself, rather than only in its potential success. Researchers in this field often speak of the SETI mindset, a combination of optimism about the possibility of discovery and realism about the challenges involved. This mindset allows them to continue working despite the absence of results, finding satisfaction in improving methods, developing new technologies, and training the next generation. The psychological reward comes from contributing to a grand human project rather than from personal recognition or quick success. The public's psychological engagement with SETI also follows interesting patterns. Interest tends to surge around anniversaries, new technological developments, or occasional false alarms, then subside during long periods without news. This pattern reflects the challenge of maintaining attention on a question that may not be answered within a human lifetime. Yet, the underlying fascination persists, suggesting that the question of whether we are alone touches something fundamental in the human psyche. This psychological dimension may be as important as the technological one for the long term success of the search. Maintaining funding, public support, and researcher motivation across generations requires understanding and nurturing the human elements of the endeavor. The search needs not just better telescopes, but also ways to help people stay engaged with a question that offers no immediate answers, to find meaning in the listening itself. The sociology of knowledge production in SETI differs from most scientific fields. In disciplines with regular experimental results, knowledge accumulates through a series of incremental discoveries. In SETI, knowledge accumulates mostly through negative results, learning where not to look, which frequencies are unpromising, which strategies are less likely to succeed. This negative knowledge is valuable, but can be psychologically and sociologically challenging to maintain over long periods. The field has developed its own social structures to support this unusual knowledge production. Small conferences where researchers can share frustrations as well as ideas, mentoring relationships that span generations, and public outreach efforts that help justify continued funding. All these social elements are essential for maintaining the search across decades. The sociology of SETI is about building and sustaining a community around a question that may not be answered within the lifetimes of its current members. This social dimension extends to the international cooperation that characterizes the search. SETI researchers from different countries and cultures work together with remarkable harmony, united by a shared question that transcends national boundaries. This cooperation provides a model for how humanity might approach other global challenges, showing that international collaboration is possible when focused on common human goals rather than national interests. Looking forward, the sociology of potential discovery is already being considered. How would the world react? How would different cultures respond? How would the scientific community handle the verification and announcement process? These sociological questions are being thought through in advance, through protocols and discussions that represent a remarkable exercise in preparing for an event that would affect all humanity. The aesthetics of the cosmic perspective infuses the search with a hint of beauty that complements its scientific rigor. The mathematics of the search has its own elegance. The Fourier transforms that decompose signals into their component frequencies, the statistical methods that distinguish pattern from noise, the orbital calculations that point telescopes with exquisite precision. This mathematical beauty provides its own reward for researchers, separate from the practical results. The technology of the search also has aesthetic dimensions. Radio telescopes are not just functional instruments, but sculptures of metal and mathematics, their parabolic curves tracing elegant arcs against the sky. The control rooms where data are monitored have their own aesthetic of focused attention, screens glowing with waterfalls of data that represent the universe's whispers made visible. There is beauty in the marriage of human ingenuity with cosmic mystery. The potential messages we might receive could themselves have aesthetic qualities. An advanced civilization might communicate not just information, but beauty, mathematical harmonies, artistic patterns, or expressions of cosmic wonder. The ability to appreciate such aesthetic elements might be an important aspect of understanding any message fully, suggesting that the search is not just for information, but for connection with other sensibilities. This aesthetic dimension reminds us that the search is about more than just acquiring knowledge. It is about expanding human experience, about connecting with the beauty and mystery of the cosmos. The act of listening itself can be a form of aesthetic practice, a way of appreciating the universe's grandeur through careful attention to its subtle signals. In this sense, the search has value, even if no signal is ever detected, as a way of engaging with the cosmos that enriches human life. The ethics of cosmic responsibility emerge from considering humanity's potential role in a galaxy that may contain other intelligence. If we are alone, we bear unique responsibility for preserving and nurturing life and consciousness in our corner of the universe. If we are not alone, we must consider our responsibilities toward other beings and how to interact with them in ways that are respectful and beneficial. Both possibilities carry profound ethical implications. This ethical dimension extends to how we conduct the search itself. The choices about where to search, what methods to use, and how to handle potential discoveries all involve ethical considerations. The potential risks of active SETI must be balanced against the potential benefits. The allocation of resources to SETI rather than other needs represents an ethical choice about what knowledge we value as a species. Looking forward, the ethics of space exploration become increasingly important. As we develop capabilities to explore and potentially alter other worlds, we must consider our responsibilities toward any life we might find. The principles we develop for interacting with extraterrestrial life might eventually inform how we treat each other and our planet, creating ethical feedback loops that improve life on Earth, even as we look beyond it. The search for extraterrestrial intelligence thus becomes not just a scientific endeavor, but an ethical practice, a way of developing our moral capacities in preparation for potential future relationships with other beings. It encourages us to think beyond narrow self-interest, to consider our responsibilities toward other possible minds, to practice the ethical maturity that might one day be required of a species that takes its place in a cosmic community. 2000 words. Section 87. The historical context of the search reveals a long human fascination with the possibility of other worlds and other minds. Ancient philosophers speculated about countless worlds populated by diverse beings. The scientific revolution replaced speculation with calculation as astronomers realized that stars were suns like our own, potentially with their own planetary systems. The 20th century brought the technological capacity to actually search for signals, turning philosophical wonder into empirical investigation. This historical progression shows humanity's growing ability to address fundamental questions through observation and reason rather than speculation alone. Each generation has built on the work of previous ones, with today's sophisticated searches standing on the shoulders of earlier astronomers and thinkers. The search represents a cumulative human project, one that has been developing for centuries and will likely continue for centuries more. The history of false alarms and near misses also forms an important part of the story. From early radio experiments that picked up terrestrial interference to more recent signals that initially seemed promising but were eventually explained naturally, these episodes have helped refine search methods and manage expectations. Each false alarm has taught valuable lessons about how to distinguish truly promising signals from natural phenomena or human made interference. This historical perspective helps maintain realistic expectations about the search. Major scientific breakthroughs often take longer than initially hoped, with progress coming through patience and persistence rather than sudden dramatic discoveries. The history of SETI suggests that the search may require decades or even centuries of careful work before yielding definitive results, but that the journey itself has value, regardless of the destination. The educational value of the search extends far beyond its direct scientific goals. SETI provides a compelling context for teaching about astronomy, physics, biology, and many other fields. Students naturally engage with the question of extraterrestrial life, making it an effective hook for learning about more challenging concepts. The search makes science exciting and relevant, showing how different disciplines connect to address a profound question. The search also teaches important lessons about the nature of science itself. It demonstrates how scientific inquiry works, asking clear questions, developing testable hypotheses, building appropriate instruments, analyzing data rigorously, and following the evidence wherever it leads. It shows science as a process rather than just a collection of facts, highlighting the values of curiosity, skepticism, and persistence that drive scientific progress. For the broader public, following the search provides a model for thinking about uncertainty and the unknown. In an increasingly complex world, the ability to live with unanswered questions, to avoid premature conclusions, and to update beliefs based on new evidence is increasingly important. The SETI enterprise, with its decades of careful work without definitive answers, models this thoughtful approach to uncertainty. The international and cooperative nature of the search also offers educational value. Scientists from many countries work together, sharing data and resources across national boundaries. This collaboration provides a positive model of international cooperation aimed at common human goals rather than national interests. In a world often divided by conflict, this aspect of the search reminds us of what humanity can achieve when we work together. The spiritual dimension of the search addresses deep human needs for meaning and connection. The question of whether we are alone in the universe touches on fundamental aspects of human existence, our place in the cosmos, the significance of consciousness, the possibility of other minds with whom we might share the experience of being. These questions have traditionally been the domain of religion and philosophy, but science now brings its methods to bear on them. This spiritual dimension does not necessarily conflict with scientific rigor. Many researchers find that the search enhances their sense of wonder and connection to the cosmos, even as they maintain strict scientific standards in their work. The careful attention to the universe's signals can be a form of meditation, a way of listening to the cosmos that is both scientifically productive and spiritually meaningful. The potential discovery of other intelligence would have profound spiritual implications for many people. It would expand our sense of cosmic community, suggesting that mind is not a rare accident, but a natural part of the universe's unfolding. This could be simultaneously humbling and exalting. Humbling because we would no longer be unique, exalting because we would be part of a larger community of consciousness. Even without discovery, the search has spiritual value as a practice of cosmic attention. The act of listening to the cosmos, of dedicating time and resources to wondering about other minds, represents a noble aspect of human nature. It speaks to our capacity for curiosity, for wonder, for reaching beyond practical concerns to ask profound questions about our place in the universe. This capacity is itself spiritually significant, worth cultivating for its own sake. As our contemplation draws toward its gentle conclusion, we return to the essential mystery that has guided this journey. The search for extraterrestrial intelligence represents one of humanity's most profound and enduring questions, an inquiry that spans scientific disciplines, philosophical traditions, and cultural expressions. It is a question that has persisted for centuries and will likely continue for centuries more, a constant companion to our species as we explore the cosmos. The silence we have encountered thus far is not evidence of failure, but an invitation to deeper listening. Each negative result narrows the possibilities, guiding our search toward more promising avenues. Each technological improvement increases our sensitivity, allowing us to hear whispers that were previously inaudible. Each conceptual breakthrough expands our imagination, helping us recognize forms of intelligence we might previously have overlooked. The value of the search lies not only in its potential success, but in its ongoing practice. The act of listening itself cultivates valuable qualities: patience, curiosity, humility, and wonder. It encourages international cooperation, technological innovation, and philosophical reflection. It inspires new generations to study science and look upward with hope and curiosity. These benefits accumulate regardless of whether we ever detect a signal. So the search continues, a quiet persistence against the great silence. The telescopes keep listening, the scientists keep analyzing, and humanity keeps wondering. The answer may come tomorrow, or in 1,000 years, or never. But the question is too important not to ask, the possibility too profound to ignore. And so we listen patiently, hopefully, to the whispers of the cosmos.